What's up YouTube? This is Dennis Panuta for tutorials.eu. In this video, you are going to learn how to build video games using C#. So we're going to focus mainly on the C# aspects of game development. So you're going to learn the fundamentals of programming while building two games. First of all, it will be a guess the number game. And then after that, you're going to learn how to build Hangman using Unity and C#. And therefore, I would recommend that you check out this video right here, which shows you the fundamentals of how to use Unity. And then you will be perfectly ready to check out this video. If you have installed Unity already and you know how to use Unity and you just need to learn C# coding, then this video is also great for you. All right, so let's get started. And also, don't forget to hit that like button as well as the subscribe button. Welcome back. In this lesson, we are going to discuss why C# is widely used and what perks it brings us. So, first of all, why is C# used for game development? Well, C# can save you a lot of time. You can save a lot of time by using C# instead of different programming languages. C# will save you the time for looking for tiny errors because C# is statically typed. Then you have simplicity and efficiency. Programmers can spend less time writing complicated stacks of code that are repeatedly used throughout the project. Then you have a low learning curve. In addition to the time you can save during project development, you will also spend less time learning C# compared to the other programming languages that are out there. C# is scalable and easy to maintain. C# is a programming language that is remarkably scalable and really easy to maintain because of the strict nature of how static codes must be written. C# programs must be consistent, which makes them much easier to adjust and maintain. And there is a huge community. In the world of coding and programming, the importance of a helpful community on which you can depend simply can't be overstated. Programming languages aren't a platform or service with a dedicated help line or convenient IT support. Programmers must rely on the support of others in the same field who have experienced the same roadblocks and frustrations. One such community can be found on Stack Overflow. Stack Overflow is a place where you can go to ask, answer, brainstorm, or vent. And, well, C# is widely used to create games. More than a third of the top games are made with Unity, and there are approximately 770 million active users of games created using the Unity engine. Unity is also used for VR, with 90% of all Samsung Gear and 53% of all Oculus Rift VR games were developed using Unity. C# makes a great choice for any programmer hoping to break into the game development industry, or for anyone interested in virtual and augmented reality. At the end of the day, well, C# is a language that is very easy to learn, but hard to master. And as we go through the course, we will be learning it step by step. And to have a good start in this chapter, we will develop a few games that heavily rely on code. And what we'll learn from these games will be the foundation of our C# knowledge as we grow as game developers. So thank you for your attention in this video. Let's get started and write some code. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount, so don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, we're going to look at our first code, even though technically speaking, we had used our first code before, but this time we're going to actually focus on the code itself. Okay, so let's go ahead and create a new project. And I'm just going to use the 3D template here. And I'm going to call this one my first code and create. So now we're creating a Unity project and the code itself will be something that we will build inside of the Unity project. So once we're inside of Unity and the project is loaded, let's go ahead and create a new script. And therefore, here inside of assets, I'm just going to go ahead and create a new C# script like so. So right click, create the script, and I'm just going to call this one my script. Okay, so you saw the default was my mono behavior, and let's go ahead and open up the script. So double click on it and Visual Studio will open up. If it didn't open up, then make sure that in your settings you have set up that Visual Studio is your default program. So here under preferences, external tools, you need to make sure that Visual Studio Community or whatever Visual Studio version you want to use is set up here. Once we are inside of the script, you can see that there is a lot of code inside of it already, and that is generated code for us. So we didn't need to create the code manually, it was just created for us because we created this script inside of Unity. So that means that Unity also added its own stamp to it. Basically, you can see here at the very top already the keyword Unity. So it says Unity Engine, and before that it says using. So what that means is that our script is going to use this namespace called Unity Engine. A namespace is basically a collection of a lot of different code. So Unity developers have written all of this code and they have made it available for us in one package. So namespace is like a package of a lot of code that we can then use. In other programming languages, you have the keyword library. So we are using a library of a bunch of different books, so to speak, and each book contains certain functionality. And we can just use those books in order to use the knowledge or the skills, so to speak, that are written in those books for our game. And we don't have to write all of the code manually ourselves. Mainly, we are going to really just reuse code that was developed before, but reuse it or use it in our own way. Okay, so of course, we're also going to see how to write our extremely custom code, so where we build everything from scratch, but most of the time we're going to use something that is inside of the packages. Because basically, if you want to access anything that is available in our Unity game, we need to access this inside of the Unity engine. Then you can see that there are some grayed out parts of the code as well, using system collections as well as using system collections generic. They are added by default as well, even though we don't need to add them here because we're not really using them. So you can get rid of them because they were grayed out already. It doesn't make a big difference because, well, it doesn't impact our code. So if you now delete this line of code as well, you will see that this mono behavior suddenly doesn't work anymore. So suddenly this mono behavior is underlined with a red line, and that means that mono behavior is one of those books, so to speak, of this Unity Engine namespace. Okay, so it's only available inside of Unity Engine, and that's why we need to add it there at the top. So now our script is inheriting from mono behavior. What that means is something that we are going to cover a lot later in the course, because this is let's say more advanced topic. But basically what it means that our script is going to learn or use the functionality of a mono behavior. So it's going to be like a mono behavior. So this is the base class from which every Unity script derives, which basically means that every Unity script needs to have this mono behavior instruction, otherwise it won't work in Unity properly. So mono, coming from the ancient Greek monos, alone, only, sole, single. Okay, so basically we have a single behavior, and that is the idea of every script. A script should always focus on one behavior only. So you shouldn't put all of your functionality into one script, but you should build multiple scripts and each having one particular task and one particular job to do. All right, and then we have this keyword public here. So there are multiple options what you could write here, public or private, even though in this particular case you have to use public because a script needs to be public inside of the namespace that we're using. So we don't have the other option here for our class, my script, it needs to be public. We're going to later see what this exactly means once we use different kinds of access modifiers. So this is one access modifier called public. And then we use this keyword class. So everything that is inside of these curly brackets here is part of our class. Okay, so basically everything that starts from here to here is part of our class MyScript. Okay, and what we can now do is we can now change the behavior of an object that uses our script. We're going to, by the way, also go a lot deeper into what classes are later on. We're going to write our own classes entirely. So for now, just consider it as the container that contains the code that then allows us to make changes to the objects and change the behavior of our objects that follow this script. All right, and then inside of our class, we have this method called start. So this here is a method and it is called before the first frame update. So the moment the object that holds the script is loaded into the game, okay, into our scene, so to speak, just before it's going to be visible, then the start method will be called. So here we can make changes to whatever should happen to the object once our game starts. You see, the name is start, and then we have these brackets here where we can add some additional information, what should happen inside of this method. It's not necessary for the start method because it's a default method. So Unity comes with default methods and they have to follow a certain structure. For example, it has to use the void keyword here, which means it will not return anything. But what returning something means is something we'll cover a lot later. And once we create our very own methods that will be changing a lot of stuff as well. For now, just remember that the start method is going to be called before the first frame, and you can actually even see that here, and here you can make changes to what should happen to your game object. Then we have the update method, and that is called once per frame. This means that this method will be executed 60 times per second if you have 60 frames in your game. So it's something that will be called quite a lot, and here you should manage your user input because your user input has to be super fast and it has to be translated into the game. That's why you have this method here by default. We're going to look at methods a lot more later on, as I said, when we're building them. For now, let's just use the start method in order to change the size of one of our objects. And here I'm going to use the transform. You can see this keyword automatically exists because we are using the mono behavior class. So this transform keyword is included there. And now we can use the local. And you can see if we enter local after the dot, we can change the local values, such as the local position, local rotation, local scale. So where have you come across these before? Well, if we look at our game and we click on, for example, the main camera, we can see that it has a transform. And there it has a position, a rotation, and a scale. So let's say we want to change the transform scale. So we want to change the size of an object. Then we can do it like so. We can change the scale by saying, okay, let's multiply the scale with 2. It will take the value whatever it was before and it will multiply it with whatever is after the equal sign. So in this case, it will multiply it with 2. So it will make the scale twice as big as it was before. And then we need to use this semicolon, and that is something that we need to use after every expression and every line, so to speak, of code. Okay, so once we finished our statement, we need to add the semicolon. Otherwise, if we don't do that, our program doesn't know when this expression is done. So when this statement, this code statement is done. So you see, you even get an error here. It says expected a semicolon. Okay, so let's add that semicolon in there. Then let's save the script by either pressing this button here at the top or by pressing Control S on Windows or Command S on a Mac. Okay, so now our first script will be done. Let's go back to our Unity project. Let's go back to our Unity project. And in here, let's go ahead and create 2 objects. So 2 3D objects. One will be, well, let's just create two cubes here. Let's call this one cube 1. And then let's duplicate it and call the second one cube 2. Okay, and what I'm going to do is I'm going to zoom in a little bit and I'm going to position them slightly next to each other. Okay, so if we look at the camera, well, maybe we should do it more like so. So this one will be at, let's say, position 3 for the x coordinate, 0, 0 for the y and z coordinate, and the other cube will be at 0, 0, 0. So if we look at our game, this is what we get right now. Okay, so now what I want to do is I want to add this my script to one of the cubes. So I'm just going to add it to the second cube, which is this right cube here. In order to add a script to a game object, you can just add it as a component. So either you drag it in here, for example, you could position it just on top of the box collider, or what you can do is you can go to add component and then search for the name of your script. In my case, it's called my script, so I can just add it this way. So if you look at it now, you can see my script is here, added to my cube 2. Okay, now if we run this, we'll see that our second cube is just going to be double as big once we start the game. And that is because we multiplied the scale. It's not even double, it's more like 8 times the size, because 2 times 2 times 2 is basically 8, right? So now it's twice in all dimensions, and that's why this cube appears to be a lot bigger. And that is because we changed the scale, the local scale of our object that holds the script, this my script. Now for you, as a little challenge, add this script to the other cube also. Okay, I hope you tried it. So let's go over to cube 1 and let's add the component my script. Let's run the game. We will see both cubes are now a lot bigger. All right, and now a little other challenge. Create another script that will change the size of a third cube to 3 times the normal size. Okay, I hope you tried it. So let's create a new script. And I'm going to call this one enlargen. Something like this. And what this enlargen script will do, let me double click on it so it opens up. And here it will change the transform dot local scale to multiplying it with 3. So star equal 3 semicolon. Let's save the script by pressing this button or Control S. And then let's get back to Unity. And now let's add a new cube here. So 3D object cube. I'm going to call this one cube 3. And I'm going to add the component enlarge in here. Like so. So by the way, this cube 3 should have a different position. So let's change it to, let's see, -5 for the X position. Like so, it will be here at the left-hand side. And let's run it. And there we are. This cube is a lot bigger now. By the way, if you just duplicated your cube 2 or cube 1, for example, and then added the enlargen script, you would have a different behavior. So you can see now you have the my script as well as the enlargen script. So you have 2 scripts which actually both change the size. So one is going to 2x it and the other one is going to 3x it. So let's run this and we will see that we now have this huge cube, this one here, and it has a scale of 6 because 2 times 3 is 6. So 6 for x, for y, and for the z coordinate, which is why we have now this huge cube, this one here, which basically is on top of the other cubes here, you see? So we could of course change its position like so, and then you can see it's a lot bigger and it's on the side here. Okay, so that's it for this video. In the next video, we're going to look at code a little more. Welcome back. In this video, I want to introduce what we're going to build next, and it's going to be this little game. And while building this little game, you are going to learn a couple of fundamentals of C# programming. So you're going to learn how to code your first code. And that's really something that is super important when it comes to game development, because you will need to be able to code in order to build super advanced games and basically have the entire freedom to build whatever you want, because code is really just such a powerful tool. So here you can see it asks us to guess a number, and we can just enter it here. Let's say we enter 42 and we guess, and then it says whether the number that was thought of by our game is lower or higher. So it says try lower. So let's try 13, and it says even lower. All right, let's guess 7, and there we are. So it was correct. So the guessed number was 7, and now if we rerun the game and we enter 7 once again, and guess it, you see try higher is stated. So the number will be randomized and it will be different every single time that we run the game. So that's really the whole idea of the game that we're going to build. And while building that, you are going to learn a bunch of fundamentals of C# programming. You're going to learn how variables work and what data types are. Then you're going to see how to use methods, then also how to use the debug functionality in order to write something onto the console, and then how to use if statements so that a particular code is executed if a certain condition is met and otherwise do something else, and so forth. Okay, so I'd say let's get started in the next video. Welcome back. In this video, we're going to set up our guess the number game, and we're going to set up the UI of the game. And then in the next video, we're going to start writing our first code for it. So let's go ahead and create a new project. I'm going to use 3D here, and I'm going to call this one guess the number. So the goal that we have for this video is to set up the game that it looks something like this. It doesn't have to be exactly like that, but overall that's more or less the goal. So let's go ahead and set that up. Therefore, what we will first of all do is we will save our scene with a different name. So let's change the name of our scene, and I'm going to call this one game scene instead. So let's reload the scene because we already have it open. The sample scene is currently open. So let's rename it, and you see now the name has changed here at the top as well. So what we are going to require are 3 UI elements. It's going to be the text, a button, as well as an input field. Okay, so let's get started. First, let's set up the text, and let's go over to the scene view and look at our text. Therefore, we can move a little bit around. So let's change it like so. And we can see, okay, this is where our text will be positioned inside of our UI, like so. So the text can just say new text. It doesn't have to say anything in particular at this point. We will change, however, the font size. So let's go over here on the right-hand side and change the font size of our text to something like 48 pixels. Okay, so it's going to be quite big, and you already see that even the new text is not visible anymore. So here you see it's not visible in game mode. In order to make it visible, what you can do is you can either change the size of the text here at the top, or you can make sure that it overflows. So horizontal overflow, let's set that to overflow. And the vertical overflow, let's set that to overflow as well. So now our text will overflow, so to speak. So even if it doesn't have enough space inside of its container, so here the container is 160 times 30, it will still be visible and displayed. Now let's change something with our game window here. So by default, you can see it sets to free aspect. And I'm going to deactivate this low resolution aspect ratios, and then it will automatically adjust it so that our screen will automatically scale based on what we set up here. So it's basically scaled in here. And then if I change here, you can see if I change the screen size, it will follow the new aspect that we have set up. What I want to do, however, is going to be a full HD setting. So let's set that up to full HD here. Let's deactivate low resolution aspect ratios, and then we should get the screen how it should look like. So the text of 48 seems to be fine. Of course, you can play around with the values, so maybe you want it to be even bigger. So here you are free to use whatever size you want to use. Okay, now that's our text, and we can of course also change the color. So we can select a very bright green color, so to speak, and that should look a little better, even though it doesn't look good with the horizon in the background. So how can we change that? Well, you can go over to your main camera, and here under the camera component, you will find the clear flags, and it says skybox. And here you can select solid color, for example, and suddenly the background has a solid color. And I wanted to use a grayish color, a dark gray, something like this. Here you can play around with the values, select the gray that you like, and then this green will pop out a lot better and will look a lot better as well. Now there's something else about the text. Let's go back to the text. The text now is not really centered. And that is because if we look at the paragraph alignment here, you can see that it's aligned towards the left and towards the top. So in order to change that, we can align it towards the center in both directions. So inside of its container, which is this 160 width and 30 height, it will now be centered. You can see it a little better from here that now it's going to be centered inside of this white box that we have here. Of course, you can change the box size as well, width of 300 maybe, and the height of 50, for example, then it will be inside of the box. But because we overflow, it doesn't really matter too much. Okay, now let's go ahead and create a button. And this button is now exactly on top of our text. I want the button to be in fact in the middle, and underneath I want to have the text. So first of all, the button should have a different text. So underneath the button you can see that there is this text property, and I will change that text to guess. I'm going to change the font size as well to 48. Therefore, of course, I need to make sure that my button is going to be a little bigger. So let's change the width to something like 200 and the height to something like 50 as well. Then we will see that our text is still not there. So how can we fix that? Well, you can go over to your text and play around with the font size. You can play around with the overflow. You can check out if with overflow it works, and you will see this is how big it would be. Or maybe you can also just change the font size up a little bit. So something like 36 may be a little better. You can go back to the default values using wrap and truncate, even though here it doesn't really matter too much because, well, we don't have much text that we are displaying in here. So this overflow basically just allows us to overflow of the boundaries. Truncate will basically cut it off at a certain point, and wrap will try to wrap the text and push the extra text into the next line. So if I had a very long text here, you can see if I wrap, it will be limited here. If I overflow now, it will overflow in the horizontal direction. And then if I overflow on the vertical direction, you can see then it will overflow vertically and all of the text will still be displayed. So that is something that you can play around with. I'm just going to have the guess text like so. Now, of course, because our button is in the way of the text, let's change the position of the text up a little bit. So you can see it's in the center. So the anchor presets are middle and center. And I'm going to change the Y position. I'm going to put it further down like so. So I'm going to use something like -100. Okay, so let's look at our game. You can see it's at -100. It looks quite okay. Actually, we can also see that maybe our button is too small now. So maybe we should play around with that. That's really something that you can test and find the right size for you. Okay, so the button maybe all 300 would be better. So 300 width and 80 height. Maybe that's a little better. Then the text should be bigger and so forth. So it really is up to you how you want it to be. Okay, and then we need to have an input field. So here UI and then select input field. And now let's change the position of that input field to 100 for the Y position. So it will now be on top of our guess button. Let's also change the size here to 300 times 80. So it will be the size of our button. But now you see that the text that our input field has to offer, this enter text ... which is going to be a placeholder, this one here, is rather small. So let's change the font size of that as well to something like 48. And then the text of the input field, let's change that to 48 also. So whatever we enter now will also have a font size of 48. Now, if you look at this text field and you scroll a little bit down, all right, and now inside of our input field, so click on the input field, there you see that there are a bunch of other settings also, like the image that you have as a background. So if you wanted, you could add a background here. Then the fact that your input field has a certain color, so you can change the input field's color as well. So also the background color. So either you assign an image or the actual input field color. You can play around with that. Once you hover over it, once you highlight it, how should it change the color? So for example, highlighted color, if I change that to this green color, for example, and now I run it, and now let's highlight it by hovering over it. You see now it's highlighted and it has this highlighted color. Okay, so that's something you can play around with. Then what should be the disabled color? So once we deactivate our input field, or the selected color and so forth. So you can really play around with those values here. But the thing that I actually wanted to talk to you about is going to be the content type, because I want to make sure that we cannot enter whatever we want in there. Because if we run our game now, we can see that we can enter letters, we can enter numbers, all the good stuff. Okay, so let's change that. What we want to change it to is going to be an integer number. So here the content type should be integer number. So integer numbers are whole numbers. So now this text input field will only accept whole numbers. So let's run this real quick. And now let's try to enter Dennis. You can see, well, it doesn't accept anything, but numbers are accepted, as well as the comma and the dot are not accepted either. So basically only whole numbers are accepted, and that's exactly what we want. And I'd say that's it for this video. So now we have set up our UI so that we can actually play around with it in the next video and add a little bit of code to our game. But for now, our UI is ready. So you saw a couple of things. First of all, how to use an input field and how to define what kind of data you can enter in there. You saw how you can change the clear flags to solid color in order to get this background, which is a solid color, instead of using the skybox, which is also very nice, but not for our game in particular. And then you saw a bit of settings for your graphical user interface as well. All right, so that's it for this video. Make sure to save your scene as always when you're done with your changes, and see you in the next video. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code, as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, we are going to link a script to our button. So let's go over to our assets folder, and now let's create a new folder here, which I'm going to call scripts. Inside of this folder, I want to have all of my scripts. So for now, let's create a new C# script inside of this folder, like so. Create C# script, and let's call this one game logic, like so. So this game logic script will now contain the logic of our game, and it will contain, so to speak, the behavior that in our case the button should have once we click on it and what it should do. So for now, let's open up this game logic in Visual Studio and see how we can actually run something once we clicked on a button, for example. Okay, so inside of the script, you can see we have all of the default code, such as the start method and the update method. And now what we're going to do is we are going to create our very own method. Okay, so in order to create an own method, first of all, you need to add the access modifier. An access modifier is a keyword such as public, private, or protected, like so. So these are the different access modifiers that you can have, and you can also have the empty access modifier. So here, for example, you see there's no access modifier. So they didn't add the keyword public here or the keyword private here, because these methods, they are specific to this class, so by default they will be private. So these methods, they are by default assigned to an individual class. So what we can do now is we can create our own method using the public keyword here, for example, because we want to make sure that this method is going to be accessible from outside of the script also. Then we need to say what kind of return type we want to have. So here, for example, void will be the one that doesn't return anything. And you see void was used here before. Void means basically an empty space, so it's going to return empty, so it's going to return nothing. And that's fine because we only want to execute something. We don't want our method to return something. So there are methods that either return something where you give them some values and they do something with the values and then give you something back. So it's like a box where you have an input and then you do something inside of the box and you get an output. And then there are the methods where you have an input and you don't get an output. So the method just executes something with the input. And then you have the methods which have just have the box. So no input, no output, they just execute some code, they just do something. Okay, so we are going to have the one that doesn't require any extra data. So it's just going to execute a code block. Okay, so I'm going to use this one on button click, like so. And every method needs to have these brackets. Okay, so this is how you define a method using the access modifier, the return type, the name of the method. I'm using on button click, and you can see the first letter of each word is with a capital letter, and the method name also starts with a capital letter. Then you have the brackets, opening and closing. Here you could add the input that you want to give. And then we have the curly brackets in which we can now add our code block. So here, our code block that we want to execute once this method is called. So once this method is executed, the code inside of the code block will be executed. So that is a very clean way to separate code from one spot to another to make sure that you have clean code. Every method should just have one purpose. Okay, so it should just do one thing, so to speak, but it doesn't mean that you just have to have one line of code. It can have multiple lines of code here. But the goal is to only serve one purpose. Okay, so in this case, once the button is clicked, here we want to execute something. And you can see what we have here is a comment. So this is code that will not be executed by our program. It's just for us as developers. So we can now see that there is this text code block, but our game will not care about this. So it will not do anything with this text here. It will not execute it. The compiler doesn't care. So basically the thing that makes this code understandable for our PC will not care about this. So what I want to do here is I just want to use the debugger to write something onto the console. You might recall we had this keyword console before, and that's this window here. So there's this console, and I would like to write something onto the console once we press on this guess button. So how can we achieve that? Well, let's go over to our code and actually say what we want to do here. And I'm going to use this debug keyword, and you can see it is offered to me by Visual Studio because it's part of the Unity engine. So once you hover over it, you see class Unity engine. Where did you hear that word before? Well, up here. So we are using this namespace called Unity engine, and inside of this namespace Unity engine, there is a class called debug. So it's basically like a book that has a bunch of functionality in it. Okay, and we are using that book inside of this library of books. So inside of this namespace. So now this debug is a class, and a class can have multiple methods as well as properties. We're going to look into what methods and properties are in depth a little later. We're going to see how we can create our own classes later on as well. But for now, just try to understand that this is basically a book that can do things for us. So it has on one hand some properties which describe how this debug is going to be like. And then it has methods that allow us to execute something. So to be active and activate something. So in our case, the action that we want to do is we want to write onto our console. Okay, so in order to write something on the console, we need to use the log method. So you can see there is this method that will log a message to the Unity console. That's exactly what we want. So now in here, we can write in quotations what we want to say once we clicked on the button. So what I want to say here is who clicked me. So our Unity console will be very angry. And then you see, after that, I add the semicolon. And as you learned earlier, whenever you finish a statement, you need to add the semicolon in order to say, okay, this statement is done. There is no more code coming that is part of this statement. Okay, so every single statement needs to be finished with a semicolon, and the next statement goes then into the next line. Okay, so in this case, our debug will call the method log, and the log method, we are passing some data to it. We're passing the data, so the text that we want to display once we clicked on the button. So now let's save the script by pressing Ctrl S or by saving it from here. And that is generally something that you will need to do, even if I don't specifically say that you should save it. Every time that you make changes to your script, you need to save it before those changes will be noticed inside of your Unity project. So otherwise it will not be available in your Unity project. At least not the changes. So now if we look at our project, in the scripts folder we have this game logic script, but only because it's there, it doesn't do anything, because it's not assigned to any game object or UI element. So what we want to do is, we want to add this game logic to our game. So what I will do here for is, I'm going to add a new game object, an empty game object, that I'm going to call game logic. And this game object, well, I'm going to reset it first, because it's always nice to have your game object at the 000 position. And then I'm going to assign this game logic script to it. So I'm going to drag the script over to the game logic. You could have alternatively also just added the component using game logic like so. If you have it twice here, get rid of one of them, because you will only need the game logic script once assigned to your game object. So on one hand, we have the script called game logic, and on the other hand, we have this game object called game logic. So what we want to do now is we want to execute a certain method once we click on the button. So let's go over to our button and then go over to our button component, to this one here, and you will find that there is this on-click area. So here you can say what should happen once you click on the button. So let's click this plus button, and then let's drag our game logic in here. And once we've done that, we can now say what we want to execute. So from the game logic component that we added to our game logic game object, I want to execute a method. So you can see there are a bunch of things that are there by default that every mono behavior just has by default. But there is one thing that is not there by default, and that is the one that we have added ourselves, which is the on-button click method that we have added ourselves. So let's now select this, and now our code is connected to the button here. So once we click on the button, the on-button click method of our game logic script will be executed, which means that it will now execute this code here, this on-button click code, which then means it will just write something onto the console. So it will use the debug class in order to log something, so in order to write something onto the Unity console. So let's now run our game and see if this is actually going to happen. Let's click on this button, and you see here at the bottom it says who clicked me. But then you can go over to your console and you can see that at 13:18:46 the debug log was called and it said something like who clicked me. Now let's click again and again, and you can see every single time that I click on it, it will say who clicked me. Okay, and that is how you can connect your code to a button and how you can write your own code actually as well. We saw a little bit of what methods are, but no worry, we're going to go into methods a lot more. So we're going to build so many different methods that it will become second nature for you at one point. So whatever you learn in this course, don't worry if you didn't understand it at the first time, because we're going to use the things that we're using a bunch of times. And every single time that you see it in a different context, it will add to your understanding of that thing that you are learning, which will then make sure that you will definitely understand it. It's like language learning in general, where you learned a word and now you know that a word means something in a particular context. But then if you see the word in a different context, now you will learn that the word has more meanings, so more depth to it. And at this point, you will understand the word a lot better. And the more often you come across this word, the better you will understand it. And it's the same with programming, okay? So thanks a lot for watching this video. See you in the next one. Welcome back. In this video, we are going to get started using variables. Variables are going to be a tool that allow us to use text that we can enter here and then run it through a certain algorithm. We're going to use a very simple algorithm here, of course, but basically a tool which will then take the number that we are entering and will compare it with the actual number that the computer thought about. And at the beginning, we're going to use a fixed number that the computer will think about. So we're going to hard code the number in, but later on, we are going to see how we can generate a random number here for as well. So let's get started by checking out what variables are before we're going to use them in our C# code. All right, so first of all, what are variables? Well, a variable is a container that can take a value and store it. And maybe after some time, we decide to store another value in the same variable. Well, let's look at this trivial example. Imagine you are in an open buffet and you want to take a cup of coffee along with an amazing cake. You would need a cup for the coffee and a plate for the cake. Because a cup of coffee is made in order to take liquids, not a cake, putting the cake in a cup of coffee would not work because it won't fit, and probably because people will stare at you and think you're crazy or something. So that's not a good option. This is exactly how variables work. If we compare variables to our cake coffee example, a variable must have a type, which is the type of plate or cup that you're using. So are you using a plate? Are you using a cup? Are you using something else? The type of variable will tell us what kind of data it can store, where the data in our example would be the food or drink. And because we usually deal with many variables in our games, we will need to distinguish between our variables by giving each variable a name. So we need to have a type, a name, and then the data that we want to store inside of that variable. In C#, this is how we define a variable. So let's say we want to store an integer number, and an integer number is a whole number like 1, 2, 3, and so forth. So here, int is our variable type. Then we have the name of our integer variable, and here we are using I am a number as the name of the variable. And then we have the data, which is the 5 in this case. So we're using the value of 5 as the data of this integer type variable, which has the name I am a number. And at the end, we have a semicolon because that's how we have to finish our statements in C#. And here we are using something called snake case, where after every single word, you have an underscore. So I underscore am underscore a underscore number. And by the way, here we are using the snake case way of writing a variable name. So you can see we have I as a word, then the underscore, next word, underscore, next word, underscore, next word. And this way of defining your name is called the snake case. Now let's look at some other data types in C# besides the int data type that we just saw. The most important ones that we will need to know about for now are going to be the float, which we use to store float numbers, meaning numbers that have a decimal point, like in pi, where you have this decimal point, so 3.14, the dot is the decimal point, and we can use them to store values like the speed, for example. This is going to be in general important when we are working with physics in game development. And you can also see when a number is a float, you have to add the f at the end of the name. So here you can see 3.14f for this variable. And of course the semicolon. And then we have the boolean, which stores a value which can be either true or false. So here, for example, the boolean, starting with the bool name, m underscore I underscore a underscore paper underscore cup. So am I a paper cup? And true as the data or value for that variable. So this variable will now hold the value true, which means it will be a paper cup in this particular example. We will use this to store values like is a player in the air, to allow the player, for example, to double jump. And then we are going to use strings quite a bit as well, which we use to store text. So we need to use the quotations here to specify that these are actual text and not code. So here we're saying string, which is the data type, my name, which is the name of the variable, and then we are setting the data to be Dennis. So that means Dennis is going to be the value that will be assigned to my name, to this variable. And as you see, we're using quotations to make sure that this is going to be in fact a string. So whenever you're working with text, you're going to use strings here. We can use them for things like names, but also for story elements in your game and so forth. What you can also see is that we're using suddenly a different way of writing a name. So here we're not using the snake case as we did with the Boolean here, but we're using the camel case, where you don't have an underscore that separates two words, but it's just the first letter of the next word is written in capital case. So here you see my, and then capital N, aim. So my name. And this is different to what we see here, where we used the snake case. So you are free to use either way. Usually, however, in C# and Unity development, the camel case is preferred, which is this one here. But it really depends on the company that you're working for. They might have a different way of naming their variables. And in the end, it's really just a matter of style. So you are free to call your variables as you like them. And then we have the char, which stands for character. And we can use it to store a single character. So here in this case, we're using something like an @ sign or a $sign. We can use them to store special characters because if all we need is one character, then a string is going to be an overkill since it takes more memory, which will make your game less performant. So if you want to make your game as fast as possible, be always considerate about memory. The more variables we declare, the larger the memory our game is going to require. Think of it as if you are using a very huge coffee cup to store a small amount of espresso. That's not something you would want to do. And the difference to a string, as you can see here, is that we are using a single quotation mark. So you're not using the double quotes, but the single quotes. So the apostrophes here. Okay, so that's it for the theory of variables. There are a bunch more different data types, but we're going to cover them once we get to them. For now, these 5 data types that we have met, including the integer, which is not on this screen that you can see right here, are going to be the ones that we're going to use. So see you in the next video where we're going to use variables in our project. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. Let's get started using our new knowledge about variables in our project. So here we have our game, guess the number. Now let's go over to our game logic script in Visual Studio and actually create our first variables. Okay, therefore, here at the top, I'm going to create a new variable. And I'm going to use the structure that we used before, using the int, then and giving it a name. So random num. Okay, so then after that, I can use a semicolon. So what we are doing here is we are declaring a variable. This by itself is fine. So this is how you can declare a variable. As you can see, we are not giving it a number. So we're not giving it a value, which means we're not initializing it. If we want to initialize it, we need to use the equal sign and then add the value that we want to assign to it. So let's say we wanted to assign 10 to it, we can do it this way. So now we're declaring a variable and initializing it. Now this variable will be totally fine and we can now use it throughout our class. because we created it outside of any method. We're going to see what scope is later on. For now, we're just going to take it as what it is. Declare it at the top of your class. So just once your class game logic has started. So here, just after this opening bracket, create a new line and add your new variable. Now, what you can also do is, or what you should do actually, is you should add the private keyword here. What this private keyword will do is it will make sure that this integer variable will only be usable throughout our script. So it will only be usable inside of this file. And if we now have other files, we will not be able to access this random number and change it. That's why we can add this access modifier private. Now what we can do is we can also only declare it here, or just declare it in here, the variable random num, and actually initialize it inside of our start method, which is usually a good way where you can then just define what value you want to assign to a variable. So once the game logic script, or the game object that holds this game logic script, will be loaded into the game. So let's do that. Let's use this random num, and you can already see the IDE, so in this case Visual Studio, is offering me the random num variable name that we just created. So it's a field int game logic random num. Okay, so let's use that. And now let's assign a value to it. So with this equal sign, we are assigning a variable. So we are initializing the variable, but we're also assigning a value to that variable. Okay, so let's take 10, for example. After that, we need to use the semicolon in order to finish this line and finish this statement. For now, let's actually test something. So we have this debug log on button click method that we created earlier. And now we will use this debug log in order to log our random number. Okay, so let's use debug.log and then use our random number in here, like so. So you can see we can just add the random number here, but this will just display the numbers. It will just say 10. So we can also say something like the random number is, and then what the actual random number is with a plus sign here. So here we're using something called concatenation. So basically what we're doing is we are combining the string with this random number. Now the cool thing is this log can handle this. Usually you cannot add two variables together that are of different types, because this here is a string and this here is of type integer. If you recall, we used the integer type, which is a whole number, and you cannot add a whole number to a text, but that's not what's happening here. So we're not adding 10 to this string here, but what we're doing is we're displaying this string, so this text, with the 10 as a text as well. That's what this debug log can do for us. So let's actually test this and see if once we click on the button, it will actually say the random number is and then 10, for example. So now let's go ahead and save our file and go back to Unity. Now once in Unity, let's open the console and start our game. And then once the game is loaded, press the button. So you can see who clicked me is displayed. This is the first debug statement that we used. And then we have this other one which says the random number is 10. So let me click on it again and you can see it's displayed once again. So this way we can now know which variable we have assigned in code, and we could use this even if we have created a random number, which we will do later on, which will then be actually a real random number, because right now it's really just a hard-coded 10 that we have assigned as the value in our script. Okay, so to quickly recap, what we have done is we have created a variable of type integer, which we gave the name random num. Then we saw how we can assign a value to it, either directly when declaring it or at a later point in time. So here in our case, once the game is started and our game logic script comes into play and into existence, then we assign the value to our random num. We also saw that we can use this private keyword, which then makes sure that our variable will be only usable throughout our game logic script. We can, however, also use no keyword at all, like so, or we can even use something called public int. And by the way, let's actually quickly look at what this would do for us. So let's go back to Unity after we have saved this. So make the change, go back to Unity, and then go over to your game logic. And what you will find is that now your game logic here in the script area also has this random num available to it. If it was private, that wouldn't be the case. But now, because we made it public, we can actually see it from here. So let me run the game once again and then press the button. And by the way, you can see it populated it with 10 here. So now the random number is 10. So if we change that now, let's say we make it 50 and we click the button once again, you can see the random number is now 50. And that is the cool thing that Unity allows us. It basically allows us to manipulate the variables in our script directly from the Unity inspector, which is very powerful and super useful. And that's something that we're going to use even more in the next few videos. But for now, I think that's enough of an introduction to at least the basic int type of variables. We're going to see different types of variables as we go, and then we're going to cover them in more detail once we use them. All right, so that's it for this video. See you in the next one. Welcome back. In this video, we are going to see how we can get the user input from Unity directly into our code so that we can then run code that will basically do something with the user input. In our case, what we want our code to do is to compare the user input with what we have created as the random number, which will later on be generated by our code itself. So for now, we are hard coding the value. So that means that we are defining the value as one number and it will stay that same number all the time. But later we're going to create a unique number or a random number that will change every single time that we run the game. And that is something that we want to achieve. And in order to get the data from Unity to our code, we need to do a couple of steps. And we're going to look at those in this video. So the first thing that we'll do is, well, first of all, let's check out this input field. So this input field will give us data in the form of a string, even though we are saying that the content type will only be an integer. That will become a problem later on, and we're going to see how to fix that. So before we get this problem, let's actually make sure to use this input field in our code. And how can we get this input field in our code? Well, therefore, what we can create is a new variable. Okay, so also here at the top of our game logic class, I'm going to create a new public input field. And this will be user input. So I'm going to call it user input. Now I'm getting an error, however. So what is this input field and why do I need to fix it? Because it's an error in our code. Well, the thing is, we are using a class called input field that is not inside of any of the namespaces that we have added to our code. Which means in our case, we only have the Unity engine, but we don't have the Unity engine UI. So let me copy that real quick and add .ui here. This UI namespace holds all of the UI classes. So here, this namespace, for example, holds the input field class, which basically now means that we can use the functionality that is inside of this namespace called UI. For example, input field, which is exactly what we need. So we need to get the input field, which is a UI element. And you can see that if you check here, it's inside of the canvas. And if you right click, you can see it's in UI. UI stands for user interface. And that's where our input field is. So that means inside of UI, you will also find text, image, raw image, button, and so forth. All of those that you have here will be part of it, which basically now allows us to use input fields in our code. So let's for now just use this public input field user input. And you might recall if we make a variable public, it will be visible inside of Unity, as we had with our public int random num. So let's save our script and let's go back to Unity. And now let's go over to our game logic, which holds our script, as you might recall, because we call that script also game logic, right? And we created this game object, which now holds our script. And on the right hand side, you can now see that there is not only our random num, but also our user input. Okay, so let's drag our input field in there, because you see the user input is none and then in brackets input field, which means it's expecting something that is of type input field. So if I drag it in there, you will now see that it says input field, because that's the name of the input field. We didn't change the name, we left it with the default value, and now we dragged it into our user input field variable. So now you can also click on this circle here and go to your scene, and then you will see all of the items that would fit into this description, which are of type input field. As we only have one input field, you can see it only accepts this one input field. Let's say we duplicated this input field, and now we go to our game logic. You will see both of those input fields will now be made available. That is just because our variable type was exactly of that particular type. Okay, so let me get rid of this extra input field once again because we don't need it. And now what I can do is I can actually use that input field. So whatever the input field will hold in terms of its values, I can use that in my code. So here I have this variable now, and I assigned the user input from my Unity project to it, which now means I can use it inside of my code. So a good point to use it would be probably once we click on the button, I'd say. So once we click the button, what we want to do is we want to get the user input, and then we want to basically later on compare it with the random number. But for now, let's actually make a little change here. So we don't need to have this debug log who clicked me anymore. What I would like to have instead is the user input. So let's use debug log and then use our user input dot. And the thing is, our user input itself is of type user input, but we don't want to have the user input variable, but we want to have the actual text that user input has. So we can use the text property. So here, this is going to be a property, and we're going to see what properties are in depth later on when we are building our own properties, but it would go too far at this point. For now, you should just remember the fact that classes can have multiple properties that describe them, that are basically characteristics of the object. So the characteristics of the user input would be a text, for example, but then you could also change the transform, which means the position and the rotation of that user input and so forth. Okay, but we are only interested in the text for now. So let's use that. And once you hover over this text property, you will see that it says string input field dot text. So the string means that the text that we're getting here will be of type string. So it will not be an integer. So let's actually finish the statement using a semicolon here. And let's save the script and go back to Unity, because in Unity now we can go ahead and run our game, enter a value here, enter a text, let's say 5, and then press the guess button, go to our console, and it will say 5. Where does this 5 come from? Well, it comes from our user input. So whatever we have entered. So let's say 15, you can see now it says 15. By the way, there is this clear button with which you can then clear all of the statements in your console. So if you want to clean your console, that's always a good way. So here let's enter 25. Let's click on it, and you see it says 25. If I were to say 10 now, then the number that I entered would be the same as the random number. So in this case, I would have won. So of course we would like to then change the text here, for example, to not say new text, but it would say something like you have won, for example. Okay, so that by itself is great, but I would like to have this text in a form, so this input text in the form of a number. How do I do that? Well, that's something that we're going to look at in the next video. Welcome back. In this video, we are going to see how we can use the input that we get from the user, which is of type string, and convert it into a type of integer, which means into a number, so that we can later on compare the number that we get from the user with the number that we randomly generate, because you cannot compare two things that are not of the same type. It's like comparing apples with pears. You wouldn't do that, or you can do that, but it doesn't give you any value. And that's the same thing with comparing strings to integers. And we're going to see how we can write our code so that we can convert a number that is saved in the form of a string into an actual integer number, so that we can compare two integer numbers with each other. Okay, so let's go ahead and get started with that. In order to now convert our user input text into an integer, we can use something called parsing. Okay, so what we can do first is, let's get the number that we get from the user input text and store it first. And we will store it in a string because it is of type string. So I'm going to use the name user input value, which is going to be the value that we get from the user input. Now we need, of course, a semicolon in order to finish the statement. And now we store the user input in a variable that we called user input value. It is of type string, and we're not adding any access modifiers because this variable now is inside of this onButtonClick method, which will only make it available for that particular method and not outside of it. We're going to look at scope a little later, which basically means where a variable is available and where it isn't. But for now, let's just use it as it is. So now let's actually make an integer out of this. In order to do that, we can use a new variable, which I'm going to call answer, and we're going to use int.parse. Inside of integers, there is this method called parse, and parsing allows us to convert from one type to another, which means from one data type to another. In this particular case, we want to convert from a string into an integer. So that's what this will do for us. So here, this parse method will just need to have the string, here it says string s, that we want to convert. And the string that we want to convert is our user input value. So here, user input value will do the trick for us. So now, basically answer will be the answer of our user input value as an integer, which means basically what the user has entered as an int, and we could now compare it with our random number. So for now, let's just do one thing. Let's take the answer, so whatever the user has entered, and multiply it with the old answer times 2. So what that will do is, it will basically take the answer that we have entered and multiply it with 2. So for now, let's also use the debug in order to display this answer saying twice what you entered is, and then the value that is our new answer. So please go ahead and add a new line here that will write that onto our console in Unity. Okay, so I hope you tried it. So basically we're going to use our log here saying twice what you entered is, and then the answer. Okay, let's for now test this, because what we're doing here is we're multiplying, and we can only multiply with whole numbers. So if we were to try to do the same thing with our user input value, for example, multiply with 2, let's try that. You can see this won't work. So even if we were to store that in another variable, that doesn't work because we are trying to multiply a string with an int. So operator multiplication cannot be applied to operands of type string and int. But here we're not getting this error, which means that this in fact now is an integer. Well, we saw it here, but now you can even double check it. So let's save this and let's actually run it in Unity. Okay, let's run the game, enter a value, let's say 5, and we can see twice what you entered is 10. And we can see here it says 5. So what we entered is 5, twice of what we entered is 10, and the random number is 10. Okay, so that's already good, but now what we want to do is we want to compare what we have entered with the random number. And that's what we're going to do in the video after the next one, because first we need to check out how if statements work. So how we can actually run conditional code. So see you in the next video. Welcome back. Sometimes in our games, we need to make decisions based on some conditions. And this will allow us to execute pieces of code only if these conditions are met. So let's look at the following example. So let's say we are hungry. So if we are hungry, then we want to eat. And else, if we're not hungry, let's say then we sleep. Okay, so If we're hungry, we're going to eat fries or a burger or pizza or all the good stuff that will make us satiated and happy while we're eating it, but potentially not so happy long term if we only eat this kind of stuff. So otherwise, we are going to sleep. So if we are not hungry, then let's just sleep because we are full, and sleeping is just amazing. Taking a nap is great and all of the good stuff. So the actions that we're going to do inside of the curly brackets, so inside of here, are going to be the ones that we run in the if condition. So if this thing here is true, then we run the code here. Otherwise, in all the other cases, so if it's not true, we're going to do this. In this particular case, it's quite simple. So we are either hungry or we're not hungry. But of course, we can make it a little more complicated. And we're going to have plenty of examples where that's going to be the case. So let's look at this particular if statement here. So we have a Boolean called isPlayerInAir, which is true in this case. So we are creating this variable isPlayerInAir, which is of type Boolean, and we set the value to be true. Then we are comparing if isPlayerInAir, which means if this variable is true, then deploy a parachute. So in that case, we're going to deploy the parachute here. And if the player is not in the air, then we're going to jump. So let's say we had a game where we can press a button which will make the player jump. But if he's already in the air, then we're going to deploy a parachute which will make him slow down. So this is how we could manage it using if statements. We're saying if a condition is met, do something. If it's not met, do something else. So let's look at another example here. Here we have a float called distance to ground, and it equals 0, which means the player is on the ground. Then we check if the distance to ground is actually 0, which is true in this case. And if it's true, we will make the player jump. Now we have this thing that is called else if. So we don't have else as we had before, we have else if, which means we have another condition that we're checking. Here we're checking if the distance to the ground is greater than 10 meters, we will make the player scream. That could be because the player is way up high and he's too far in the air and he's so afraid and he starts screaming. Now we could have an else block which would cover all of the other cases. So for example, the distance between 1 and 10 meters off the ground. So there the player could do something else. We could run a particular animation or whatever we can come up with in our game. So you can see you can have an if condition. Then you have an else if condition, that you can have multiple more else if conditions. And then finally you can have this else condition as we saw it here. So you're not limited to one or the other, but what is always important, you have to have the if statement first, then you have the else if statements, and then at the end you have the else statement. The else covers all of the other potential cases. So in the case where you just have a true or false statement, there will only be two cases, right? So you can either be true or it can be false. But if you are comparing numbers, for example, then it's a different story. So you could say for a set of numbers, we want to do this. For another set of numbers, we want to do that. And for all of the other numbers, we want to do something entirely differently. And the same goes for strings. You could even compare words, so to speak. So now let's see how we can connect this with our game where we get the user input and where we have our random number. And let's see how we can compare those two and see what we want to do if they are the same and what we want to do if they are not the same. So see you in the next video. Welcome back. In this video, we are going to apply what we have learned in the last presentation, which means we're going to use if statements in order to check the user input and compare it with the random number. Okay, so in the last video we saw how we can see that a number is actually a number. Well, we converted it into a number and we didn't get any problems. But for now, let's actually use this answer number to compare it with our random number. So therefore, I'm going to get rid of these debug logs because we're not using them for now. What I want to do instead is I want to check for the answer that the user has entered. So answer, and I want to compare it to a random number that we have defined. So to our variable random num. Let's also add those curly brackets because that's the general structure of an if statement. So you see you have this if keyword, then you have the opening brackets, then the comparison that you want to do, or the variable that you're checking. It could also just be a Boolean. And then in curly brackets, you have the code that should be executed if this condition here is met. In our case, we're comparing answer to random number. So how does that work, and why do we have two equal signs here? Well, what two equal signs do is they compare what is left to the two equal signs with what is right to the equal signs, and they will return a bool. So if you hover over here, you can see it says bool int.operator equal int left int right. So that will be the internal operation that will be run, and they will compare the content of the two variables, because the two variables are not the equal thing or the same thing. They are really just comparing the content. So what is inside of those variables, are they the same values? So that is what we're doing here, comparing the answer that the user has entered into the user input with the random num, which means this random number. So let's use a debug log for now, and let's just say correct. Okay, so if that's the case, if the answer and the random number are the same, then we can just log something like correct. Otherwise, for now, let's use this else block that will say debug log incorrect. Okay, and end with a semicolon. Okay, so this will be a very simple example where we just have two options. So either we are correct or we are incorrect. We're going to see later on how we can compare if the number is greater than or lower than the random number, and then we can do something accordingly. So let's save the script. Let's go back to Unity. And in Unity, let's run our game. And because we know what our random number is, so we have defined it here, it's 10. So if we enter 5 here, we will know that it's incorrect. So you can see here, our debug log says incorrect because I pressed this guess button, which then runs our code. So now let me enter 10 and guess, and you will see it says correct, because this time we have the exact same number as the random number for our input number. Now, just a little thing not to confuse you. You can play around with your random number here, because that's how we designed our game. We made this random num public. But that is not necessarily something that you want to have. I mean, for debugging, it's fine because we can now check it if it actually works, but we don't want our random number to actually be public and adjustable from here. Even though now for testing purposes, it's fine. So let's test it. Let's enter 15 now, and let's guess with 10. And you can see it says incorrect because now we overrode the number that was 10, this random num, with 15. And now 10 is of course not equal to 15. So let's go back to our code, because now we can see the answer is what we entered and the random number is what we have defined up here at the beginning, but then overrode inside of Unity at this point here. Okay, so let's stop the execution of the game, because whenever we want to make changes to our code, it's always good if our game is not running, otherwise Unity might complain. So you can see that you have the two cases and you can basically run code accordingly. In this case, the code that we're running is really just a debug log. And later on, we will see how we can actually change the text that we display here. So this new text, so that it will display either, hey, you were correct, or something like, please enter a higher or a lower number. Okay, so now let's adjust this code here so that it doesn't just have two cases, but it has three cases. Because the three cases are that we are either correct with the value that we entered, or we are higher than the value that the computer thought of, or we are lower than the value that the computer thought of. So let's add the other cases. So here we can use something called else if, as we saw in the presentation. So this else if allows us to add another condition that will be very specific. So here we can compare, is the answer going to be greater than the random number? And if that's the case, we want to display something else. We could say something like try lower. So debug log try lower. And then in the other cases, so in the else block, we can say try higher. So here, why are we saying try higher? And why are we sure that we need to go higher in that else block? Because that's the default block, so to speak. So the default case. Well, that is because we have covered all of the other cases already. And in this particular example, we only have 3 cases. So the answer is either equal, or it's greater, or it's lower. If it's greater, then we need to say, hey, please try a lower number. If it's less than, so if our answer is lower than the random number, then we need to tell the user to try higher. Now, of course, you could have said else if answer less than random number. That would have been fine as well, but it's just common practice to use the else block because it's just more efficient this way. It's not going to have to specifically check once again at this point, but it will just know, okay, if this is not the case, and if that is not the case, then this will always be the case. So let's just do it. Otherwise, if we add this else if, our compiler will also have to check this once again. So it will not be certain, but it will actually have to, let's say, use their computation capacity in order to double check this. It's just not as efficient from a programming perspective. So at this point, let's save our script and let's go back to Unity. And let's run our game. So here, let me enter 5 and it will say try higher. Okay, then let me try 8. Okay, still higher. All right, in that case, let's try 11. Try lower. Okay, let's try 9. Try higher. Okay, then let's try 10. And there we are correct. So in our case, we knew it was 10, but it was still good to just test it and see how our game is going to respond to our input. And in general, whenever you are building such a game, always make sure that you're covering all of the different cases, because you don't want to have the situation where you forgot one case and your user uses this case, or your player uses that case, and then the game just doesn't work anymore because he cannot get to the next point. All of us probably have come across this problem before, or maybe not all of us, but some of us have come across the problem where we are playing a game and we are running a quest or doing a quest in the game, and at one point the game just doesn't work anymore. The quest just doesn't work anymore because for some reason the NPC just disappeared, or maybe we killed the NPC before. In open world RPGs, the most common example right now would probably be Cyberpunk, because there were quite some situations where there were game-breaking bugs. Basically, you wouldn't be able to finish the game if you didn't play the game in a certain way, and they didn't anticipate certain scenarios in which, well, a quest wouldn't be finishable. So if you kill somebody you would need for a certain quest, then a certain element in the game wouldn't be triggered, and, well, basically you couldn't complete the quest. So you would have to load a game state a lot earlier where you, for example, didn't kill that person in the game. Okay, so all of these things are something that you might want to consider and think about when building your games. So always have this else case, which will just cover all of the other options. All right, so that's it for this video. In the next video, we're going to see how we can actually print something onto the screen. And, well, we're also going to look at methods later on as well. So see you in the next video. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code, as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, I wanted to show you a little problem that we just created and how to fix that problem. So let's run our game and see how we can basically test our application. So let's just enter a number and click this guess button, and you see it says try higher. But now let's assume we're not entering anything, so the number will be empty. Then let's press guess, and you see we get an error here saying format exception. Input string was not in a correct format. So there are multiple ways how we can fix it. Either internally we set the value to 0 right from the start. That would be an option, and it will be the default value, so to speak, for our input field. Or we could check whether the input that the user has entered is in fact a number or not. So let's do that real quick. Therefore, we're back at our code, and in our on button click, that's where we are parsing the answer into an integer, and that's also where the error was occurring, because we're trying to parse, convert, so to speak, the text into a number. And this of course only works for text that is in fact of type of a number. So if it was a letter, for example, that wouldn't work. But the same goes for an empty input. So if the user input text is in fact not a number, so if it's empty, then this code here will not work. So what we can check is if, in this case, user input value is not equal an empty string. So only then do we want to run our conversion. So here we're checking, is it an empty string? If it is an empty string, then don't run this code. If it is not an empty string, then run this code. But now we're getting another error. So it says answer does not exist in the current context. So it means that in the context of this if statement here, the answer variable doesn't exist. But why doesn't it exist? We just created it in here. Well, you have to see this if statement here. It basically is like a closed environment. Okay, and we're creating the variable inside of this closed environment. That means only if this condition is met, the variable will be created. But what if the condition wasn't met? Then this variable would never have been created. And this creates a situation where we're comparing something that doesn't even exist, potentially, with another number. And that is not going to work. So we have to put this code inside of this other if statement in here. So we can see that we are already at the point where we are using nested if statements. So we have an if statement, and then inside of the if statement, we have another if statement. And that is totally valid. You can see that will totally work and it's fine. So now let's save this script and let's actually run it. And now press the guess button and you can see nothing will happen. So we are not having an error here. We're not getting an error, and it will only run if we enter a number. But not having an error is good on all, but for the user, this is not very helpful. So if this is empty and we click on it, well, we don't know that we did something wrong, even though it says enter text, but maybe we just don't get it. Okay, so how can we fix that? Well, we can, for now, use our debug log. So let's close this and use an else statement for this if statement here to log onto the console that the user should enter a number. And the user input cannot be empty for this to execute. So please go ahead and pause the video and try to add an else block right here where my mouse is in line 46, which will take care of that and will display on the console, please enter a number. Okay, so I hope you paused the video and tried it. So I'm just going to use this display here, or this debug log, and we're just going to say something like, please enter a number. Like so. And now let's save the script. Let's go back. And now let's run it once it's done. And let's press this button and we can see, please enter a number. So now our code will actually give us, at least as a developer, a hint that we should enter a number, otherwise this code won't work. Now, of course, once we know how to manipulate this game label here, this text here, this new text, we could display the problem on this new text as well. We could just say, please enter a number, otherwise it won't work. Okay, but that's it for this video. So now you see how you can use nested if statements, that it is a valid approach. You saw that a text field can be empty, and if we try to convert it into a number, it won't work, and how we can work around it. And basically, you know how to use else statements yourself. So I hope you tried it at least and created this else statement yourself. Okay, so see you in the next video where we're going to use this text label here in order to make changes to it. So the game will work even without having the console, and we will understand how to use it properly. Welcome back. In this video, we are going to implement the functionality so that we can actually change the text that is displayed here. So it doesn't say new text, but it's actually going to display the text that we want to display. Not before we run the game in Unity, but actually while running the game. And that is something that we will do in a similar fashion as we did this user input. So we need to define a new variable inside of Unity that will then allow us to use this text. How can we do that? Well, let's go over to our code and do the same thing as we did with our input field. So let's go ahead and create a public. And now a public what? Is it an integer? Is it a string? Is it an input field? Well, it's none of those. Let's actually check it here. So let's right click and see where it is. It's UI and then it's called text, right? So let's try that in code. Let's try text like so. And you will see that it says class unityengine.ui.text. So it's inside of the same namespace as our input field. It's inside of this unityengine.ui. So seems like it's legit. It's exactly what we wanted. So let's call this one game label, or you could call it game text or something like that. Okay, now let's actually save the script and go back to Unity once it's loaded. And we will see in our game logic, game object, that our script now has this new field called game label. Now we can actually change the game label either by clicking on this button here and then select the text, but which text is it? Well, that's a little confusing because we have 3 texts in our scene. So you see here in the scene. So where do we have those 3 texts? Well, they're hidden inside of our button and input field. So here you have the text as well as this text. So we never defined a proper text name for our text item here. So let's change this UI element text here to, for example, game text. Okay, now go back to our game logic and now select the game text from here. Now, of course, you could have also just dragged it all the way down here like so. That would work as well and does basically the same thing. But dragging can be tricky because, well, if you click on it and then suddenly you can't drag it anymore. So you have to click on game logic and now you have to drag it correctly. This works well, but sometimes it's just better to search for the item. Okay, now we have assigned our Unity game object into our code. So we dragged it into here, which means that now we can actually use it in our code. So let's go back to our code and use the game label now, which is our text. So we can go ahead and, for example, in the start method, define that the game label will display a different text. So let's do that by changing the text property. So you might recall that the user input had this text property, but the game label also has this text property. Because even though it's a text, doesn't mean that we can just get its text straight away. We need to get the text using the text property. But we don't want to get the text this time. We actually want to set the text. So in order to set the text, we can just use an equal sign to assign a new value to the text property of our game label. So let's change it to something like hello world, like so. And this will be executed. So this line, basically setting the text of our game label, will be run in our start method. So basically once our game logic script is loaded. So let's save our script. Let's go back to Unity. And once it's loaded, let's run our game. And we will see that once the game is loaded, you can see it says hello world here. So now we know how we can change the text. Now let's actually adjust the text so that it displays whatever we currently have inside of the debug log. So here let me enter 25 and it says try lower. So now please go ahead and change the code. So by that I mean the code inside of our game logic here in those if statements and else if and else blocks, so that it will actually change the entry of my game label to display whatever we had inside of those debug log statements. So basically I want to display onto the screen, so in my game label, correct in the case that we were correct, try lower in the case that the number was higher than the random number, and so forth. So please go ahead and try that. Okay, I hope you tried it. So I'm just going to get this game label. I'm going to set it to be correct, like I have it from here, like so. And then I'm going to do the same thing in here and in here. So here I'm going to use try higher with a semicolon at the end. And here I'm going to use try lower. So you can see we can just assign a string to our text property. Well, because here you see it says string. So this text property is expecting a value of this type string. And this is the, well, type string basically. So now let's get rid of this hello world thingy here. And let's save our game. And let's run it once it's loaded. So here, let me enter 5 and you see it says try higher. Now let me enter 10 and you see it says correct. And let me actually enter 15 and it says try lower. So now we know how we can manipulate our UI elements using code. That's a very powerful tool. You can not only manipulate your UI elements this way, but also other components of your game objects. So you could, for example, change the position of a player doing this and so forth. Okay, so now let's actually add another change because new text is not very appealing. So if we run the game, it just says new text. So instead, I would like this to be deactivated. So how can I deactivate this text? Well, there are two ways. Either I just make it an empty text. That would be one option. And the other option would be to actually disable it or make it invisible. Let's for now just use the simple approach, and we're going to do that using our code here. And actually, let me stop running the game. And then in here, I'm just going to set the game label .text to be an empty string. So an empty string are just two quotation marks because there's no empty space, no nothing in there. It's just an empty string. Okay, that doesn't mean that the object itself is empty, but it contains a string. Okay, so let's save this and let's go back to our game. Let's run it. And you can see the text doesn't appear or isn't visible. Okay, and now once we enter a number and we click something, you can see it says try higher. All right, that's it for this video. See you in the next one. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, we're going to look at methods because we're going to use methods basically throughout the whole course. Methods are a very important aspect and we're going to see how we can create our own methods. I mean, we created a method already and we used that method, but let's actually look into it a little more because our method was very simple and let's see how methods work. So imagine we have a game where we need to calculate the same thing many times, like an angle between two objects. The code to do such things could be around 4 to 5 lines of code. Now, if we want to do this multiple times all over again, then it becomes a lot of code that we're reusing. Also, if we decided to change how the angle is calculated, and then we would need to change it in every single place. So let's say we reuse that code again and again and again, and we copied and pasted that code. But now if we change the structure in which we want to do something, we need to change it at every single spot in our code, and we need to double check where did we use the code and all of that. And this is very tricky because a lot of things can go wrong there. So that's where methods come into play. And they're very handy at this case. A method is a piece of code that we can give a name, and then we can call it by its name, and it will execute whatever code we wrote inside of it. We can also write a method that will calculate a value and return the results back to us. So let's look at the general syntax of methods in C#. First, we write the return type, which is the type of data our method will return. For example, if a method will calculate an average of some values, then the return value could be float, as we have seen. So basically a floating point value that will allow us to return proper averages, because an average of just a whole number usually doesn't make sense. We could think of return types as the type of output this method will have. Then we have the method name. And the method name is really just there to distinguish between our different methods, and we can just call them by their name. And then we have the parameters. And these parameters are the input that our method will need to do its job if it needs it. So this could be the list of numbers that the method would need to calculate the average in our previous example. And finally goes our code, which is the body of our method and what makes it unique. Now let's see some real examples. So here we have this method called getDogName, which will return a string, and it requires no data from us to work. That's why our parameters are empty. So the blue opening and closing bracket at the top right is empty. But what this method will do is it will set the name dog to Civ, and then it will return the dog name. Now let's look at another method. It's called doMath, which will return nothing but needs two numbers. So we see here it will return void, and it will require int x and int y. So it requires two integers, two whole numbers. And this method will then calculate the sum of these two numbers, x and y, and store it in the variable z, and then print that variable z. If this method was to return the results, we would need to change the return type from void to int. So if we wanted to return the number z, for example, we could do something similar to what we did here with return dog. We could do with return z instead. But what we're doing here is just printing the result. We're not just returning them. So you have a bunch of options here. You can write different types of methods however you need them. And you have a lot of flexibility, and at the same time you're making sure that your code is maintainable and a lot smoother to use, because you don't need to copy and paste code, and then if you want to make changes, you will need to make changes everywhere. So that's really the power here. Okay, so let's see how methods work in action in the next video, and we're going to use methods all over again and again. So we're going to build so many different methods throughout the course, so no worries if you struggle a little bit at the beginning. The more methods you're going to create and see how they work, the easier it will become, and at one point it will just click. Okay, so see you in the next video. Welcome back. In this video, we are going to create our first method, and we're going to use that in order to generate a random number, and this time for real, because so far we just used this fixed number that we just defined. So let's go ahead and go to our game logic, and in our game logic, that's where we're going to create our new method. And you might recall we created this method called public void on button click, which we then made available inside of Unity and used it, and it was only available in Unity because we made it public. So now let's go ahead and create a new method, and I'm going to create it down here. So let me shut this down a little bit, or collapse it, and you can see that now I'm just inside of my class. So let me scroll out a little bit, and you can see I'm just inside of my class, and I don't need this void update. Let's actually get rid of it now. And this is where the class closes. So we need to create the method before that. So you have to create a method outside of other methods, but inside of the class that you want to use the method in. And of course, if the method is public, you can use it outside of this class as well. But for now, we're going to create a method that will only be executable from our game logic class. So we're going to make it private. So we're using this private keyword, which is the access modifier. And then we say it should return something. So this method here should actually return a value of type integer. Not like the method that we used so far, which was this void method, which didn't return anything. And let me scroll in a little again. So now we are actually going to return of type integer. So basically a whole number. And now we need to give it a name. And method names are always starting with a capital letter. And we are going to use, like Unity does, the camel case. So get random number will be the name of the method. Now, to get a random number, we need to say in which range we want this number to be. So what will be the minimum number that we want it to have, and what will be the maximum number that we want it to have. So in this case, I'm going to say that the minimum number will be called min and will be of type integer as well. So here we say int min, and then a comma to separate it from the next parameter. So this here is a parameter. And we're going to give this method multiple parameters. So I'm going to use int max here. So now we have two parameters, and then we need to use the curly brackets in order to say what should happen once this method is going to be called. Now you see that Visual Studio is complaining. That is because not all code paths return a value. So we said that it will return an integer, but our method doesn't return anything. That's why we're getting this error here. And by the way, we're using these int min and int max in order to basically limit which numbers our random generator, so this method here, will return. Okay, so here I'm going to use int random. This is how I'm going to call this variable, random. And it will just hold a random number. And I'm going to get that using the random.range with min and max. Like so. And then it will return our random value, which is our random variable. So now you see the error disappears. So what we did here is we created a method. It will be private, which means it will only be available inside of our class, which is going to return an integer, which means it will return a whole number. It has the name of getRandomNumber, and it has an input of two values. One is going to be a number, which will be called min, and the other one will be called max, and it will also be of type int, which will also be a whole number. You can also see that it says parameter. So these two here are the parameters. So inside of the brackets here, you set the parameters that you want to give your method, and they are the input of the method. And you need to return the output of the method, because we don't use the keyword void here like we did with other methods. We use the keyword int, which means we're going to return an integer. Now you could of course also return a string, or you could return a bool, or you could return a float. All of that would be fine depending on what you want to do with a method. But in our case, we are going to strictly return an integer, because that's what we're going to do in our method body. So the code that goes into the curly brackets is the method body. This whole thing here is a method. And in the method body, that's where you have your logic that should be executed. Basically the box, so to speak. So you have an input that goes into the box. This is what happens inside of the box. And then this here is actually what will be the output of the box. And here you're defining the type of the output of the box. So basically we have a random generator now. Now this is of course just for demonstration purposes. In a real world example, you would directly use this random.range, because basically it does the same thing as our getRandomNumber method. But I believe that this is a good example of showing all of the different parts of a method, including the access modifier, the data type, the name, the parameters, and of course the return type. Okay, so now let's use our getRandomNumber, because what we want to do is we want to get the random number, and then we want to basically state whether we guessed the number correctly or not, which we already implemented. So let's use this getRandomNumber method in order to define a random number each time and assign it to our variable called randomNumber. So instead of defining the value as being 10 all the time, we're going to use our method that we just created called getRandomNumber, and we're going to give it a minimum value of 0 and a maximum value of 20, like so. And now of course we could change the game label text to display something like guess a number between 0 and 20. So now our random number generator will create something. So here you can also, by the way, see once you hover over this range here, it says min inclusive, max exclusive. So that means actually we're saying between 0 and 19. So if we wanted to have a number between 0 and 20, we would have to pass 21 because the 20 is actually not included. So in this case, the 21 is not going to be included because if we hover over this range, you can see max exclusive. Exclusive means not part of. So inclusive means part of. So that's going to say the random range, so the number here will be between whatever we enter here and one less than whatever we enter here. So basically, in our case, we are using the min and max values that we are passing to our method, which means the 0 and 21. So you see here, this is where we pass the 0 and this is where we're passing the 21. And we're passing them into this other part of our code. You could now, of course, use the debug log in order to say what min is. Min is, and then plus min, for example. And then debug log max is, and then plus max. Okay, and you can see that this is where we declared the method. This is where we created the method, and now we can use it throughout our code. So we can just use it in here. Then if we wanted to, we could use it in our on button click. So here we could use the same method also, and so forth. Okay, so we are free to use our method all the time. So basically it's a code block that we created and now we can reuse wherever we want inside of our game logic script because we defined it to be private, which means it will only be available inside of this class. We're going to later on see what the advantages of using public over private in some cases are and what the disadvantages are as well. So now at this point, let's save our script using Control S or Command S, depending on what you're using as a system, and test our game. Because now we should actually be able to play the game. So let's run it. And then it will say, guess a number between 0 and 20. Let me enter 15. It says try higher. Okay. Let me enter 17. Still higher. Okay. 18. Still higher. Wow. 19. And it was 19. Okay. So that is it for our game basically. So now we have a game where we can actually guess what number the computer thought of. So let's rerun this game. So run it again. Okay, guess a number between 0 and 20. Let me enter 5 this time. It says try higher. Let me enter 20. What would be the highest number? 15. And it was 15. So each time we run our game, it will now generate a new random number. All right, and that's it for this video. In the next one, I have a little challenge for you where you can try to implement basically saying how many tries we needed in order to guess the number that our game thought of. And yeah, see you in the next video. Welcome back. In this video, I have a little challenge for you, and that is I would like you to add the min value as well as the max value for our range of the random number to be visible inside of the script here. So instead of random number that we have here, I would like to have a random min number and the max number here so that I can define them directly in Unity before running my game or even while running my game to have different numbers that we can guess between. So please adjust the code so that that is given. All right. So let's go ahead, let's get back to our code here. So we have our random number and it was public, but we first of all make this one private because we don't want to see the random number itself in our Unity editor and it shouldn't be adjustable from other classes. And now let's actually create the two variables that will take care of the minimum as well as the maximum value. And they're going to be both public as well as integers, and I'm going to call it min value for the minimum value and max value for the maximum value. And now the random number will not be hard-coded as we have it here, but it will be between the min value and the max value, like so. And then what I want to display here is also going to be guess a number between, and then of course we need to display the right values here. So between plus min value, and let me get rid of this here, and then again another plus, and the max value. So this will be plus, and here I'm going to use max value -1 because the max value itself is not included anymore. So we need to reduce it by 1. If you did it without this -1, then you almost did it right, but adding this -1 will do the trick. And you can see we need to use brackets here because otherwise this statement doesn't work. Because we cannot run a mathematical operation inside of a string. That doesn't work, except we are using the quotation marks, which will now treat this whole thing as an integer. So whatever happens inside of it will be an integer. Okay, so now if we save this script and we go over to Unity, we can now define the min value and max value. And now let me define those values. So let's say between 15 and 25. Now let's run the game. And you see, guess a number between 15 and 24. So let me enter 23, okay, 21, 22, and there we are. So our game still works correctly. Now, of course, you could go as far as to say, well, here we need to make sure that the min value is in fact going to be less than the max value, but I'm going to assume that whoever develops the game and has access to the Unity tool and can change these numbers will know that the maximum value has to be higher than the minimum value. Okay, that's it for this challenge. See you in the next video with another challenge. Welcome back. In this video I have another little challenge for you, and that is the following. Since even after we guess the right number, the game still goes on and we need to implement a way to stop that. So change the code so that when the answer is found, the game won't accept any further answers. And then a little hint, a button has a Boolean variable called interactable. Simply set this variable to false when the user gives a correct answer. We will need to add a reference to our button in the script, however, in order to do that. Okay, so pause the video and try to finish the challenge. Okay, so I hope you tried it. It was probably not so easy, but that's fine. So first of all, we will need to have a reference to our button. So let's add a button in here. And I'm going to call this one game button. Now you see if you hover over it that it's also inside of Unity Engine UI, and then there is this class called button, similar to what we had with text and input field. So now this button will have a property that allows us to deactivate it. Okay, in order to deactivate it, we need to use this property called interactable. And where would it make sense for us to use this? Well, it actually makes sense in our on button click in here. So here, once we know that we were correct, we can go ahead and use our game button to use the interactable property and set that to false, like so. And at this point, we cannot press the button anymore because once we were correct, we will not be able to press the button. Okay, so that's basically it. Let's now save this script. Let's go back to Unity. And here, let's go to our game logic and make sure that we drag our button here to game button or select it from here. And now our game button will be defined in there and will be deactivatable, so to speak. So let's run it. And let's guess the right number between 15 and 25. Of course, 13 is not an option here because it's not between 15 and 25. Lower, okay, 16. Well, in that case, it's 17. And we can see that our button now is not interactable with. Okay, and now I would say this is probably going to be too much of a challenge, but still, what I would like you to try now is to adjust the game. So once you have found the solution, instead of making the button uninteractable with, instead what we want to do is we want to reset the state. So what do we need to reset? Well, we need to reset the text here, as well as we need to reset the random number. So we need to create a new random number. Okay, so you can either try that or you can just follow along. So if you want to try it, pause the video now. Okay, I hope you paused the video and tried it and you were successful. And if you weren't, no problem at all. So basically what we want to do is we want to use that same code that we did here and redo it once we won the game, so to speak. Okay, so I'm just going to create a new method here, private void reset game. And the only thing that it will need to do is to run these lines of code. So what I can do now is I can cut them out and now use reset game inside of the start method. Now, of course, it's not resetting at the start method, so you could call it set game, for example, but resetting the game at the beginning of the game is not a bad idea. It's totally fine. So now we can actually reset the game once we have the right answer. So here we can comment this line out where we make the button uninteractable with, and we can actually call our reset game method. So reset game like so. And now let's save the script and go back to Unity. And now let's run it. And it says guess a number between 15 and, well, it's actually, let me change that. Let me make it easier for myself. So it will be a number between 1 and 3. Because then it will only, or 0 and 3, because then it will only be able to select 3 numbers. So let me enter 1, try higher, 2, and then it refreshes it. So it says guess a number between 0 and 2. So in this case, we could change a couple more things. So we could reset the text that is displayed here. So we make sure that it's empty again. So in order to reset the game then, what we also need to do is we need to reset the user input. So here, user input dot text should be set to an empty string. So we want to reset it, right? So now let's run it again. Let's save this script. Let's go back to Unity. And actually, let's stop the game, clear the console, and now rerun the game. And let's guess it, try higher, okay, 2. And now you see it says enter text, guess a number between 0 and 2. So 1, try lower, okay, let's enter 0. And it says guess a number between 0 and 2. So what we could of course now add is another text that says you won, or we could display the text you won here. But then we would also have to check if we just started the game or if we reset the game. So we would have to have another variable up here, and this one can be private because it doesn't need to be used anywhere else. And this one will be a Boolean, is game 1. And this one will be set to false by default. And now if we won the game, so here at this point, we could set the is game 1 variable to true. And then once we reset the game, we could set this variable back to false. So is game 1, let's set that to false. By the way, if you didn't come up with this in your solution, it's totally fine, because it was really not that in-depth stated. So this is really just to teach you a little more about other things that you should consider. So here we also need to check if the game is 1, so is game 1, and if it's true, then we want to change the label to something else, and we want to make sure that the game is 1 set to false. So you won, and now guess the number between so and so. But else, what we need to do is we need to change the game label to just guess a number between so and so. So if the game is not 1, then we have just started the game and we're going to set the text to something default. And if the game was 1, then we're going to display you won, and then we are resetting the is game 1 variable, because at this point it is set to true. Okay, so this is an if statement that we're using here, and we're checking this variable. And basically the condition in those brackets has to be true, right? And if the condition is just a Boolean, then basically the Boolean has to be true for this code here to be executed. So by default, when we run the game, this will be false because we define it as false in the declaration of the variable here. So we initialize it with false. But once we actually play the game and we have 1 and we had the right number, then the value will be set to 1 and it will display a different text. So now let's save the script once again. And let's also make sure that we save our game scene, by the way. Let's run it. And let's enter a value here. Okay, it says you won. Guess a number between 0 and 2. 1, we won again. Okay, this time we lost. And of course we're winning all the time because I just have 3 values in between which I can select. But if I had 10 values or 15 values, it would be a very different story. Okay, so that's it for this video, and actually also for this game. In the next one, we're going to learn a little more about the general concepts of C# programming. So see you there. Congratulations, you're a coder now. You have built your first game using code, and you used C# code, you used a bunch of the features that C# has to offer. Of course, there's still a lot more to learn, which you will do in the next chapter, and of course in the following chapters in general. So at this point, you have used variables, you have used if statements, and you've seen methods, you've seen what properties are, and a lot more. So let's extend on that knowledge in the next chapter. So now that you have acquired the first skills of C# programming, it's time to extend on them. And we're going to do that by building a Hangman game. We're going to use Unity in order to create the graphics, and we're going to use C# code in order to build the logic behind it. And we're going to learn a lot more about programming, so you're going to see a lot more about methods, you're going to see how arrays work, and so forth. So let's get started. Welcome back. In this video, we're going to set up our project, our Hangman project, as well as create the user interface for it. Okay, so let's go ahead and create a new 3D project. And here I'm going to name this Hangman, and then let's create it. And once Unity is loaded, let's go ahead and set up the UI properly. So the first thing that I'm going to do is I'm going to rename my sample scene. So I want this scene to be called game scene. Okay, so let's rename it game scene, and then let's reload this scene from here as well. So now we have this game scene, and inside of it I want to create UI. So I right click and create the user interface. The first thing that I'm going to use is going to be an image. So I want to have an image as the background. Now the thing is, in order for it to look the same for all of us, you should select QHD here, 2560 times 1440, and then the values should pretty much be the same. So let's click on this image and change the rect transform here. So the image should not be in the center, in the middle, but it should be stretched. So here you see on the right hand side in the column stretch, you can select whether you want to stretch, for example, towards the right, whether you want to stretch the top to the right, and so forth. I want to stretch to both sides. So here at the bottom right, you will find the stretch that I want to use here. This will then stretch the image accordingly. Now, the left position will be 0, the top position will be 0, the right position will be 0, and the bottom position will be 0. What that will do is it will create this background or this image that will basically span across the entire screen. Now let's go over to our canvas, and in the canvas component you can select render modes. So the one that we use by default is screen space overlay. The one that I want to use is going to be screen space camera. Here, if you want to use that, you need to define a render camera. In my case, I'm going to use the main camera for that. So let me drag that in there, and this will allow me to just have a different render mode for my UI. Because we're basically building a UI based game, not really working with a player object or graphics or anything like that. We're going to mainly really work with UI elements. So here, the render camera, set it to main camera. And by the way, if I am using anything that you don't fully understand, or if you're wondering what the exact things do, the exact properties here do, you can just click on this question mark here. Then the references in the manual will open up. So what you can see here is that we are now in the Unity manual for the version that we are using, and we can see all of the details here. So the different options that we have for the render mode: overlay, screen space camera, world space. And if you scroll down a little bit, you will see the difference between them. So here, for example, in screen space overlay, in this mode, the canvas is scaled to fit the screen and then rendered directly without reference to the scene or a camera. In the screen space camera, which is the one that we're using, in this mode, the canvas is rendered as if it were drawn on a plane object some distance in front of a given camera. The on-screen size of the UI does not vary with the distance, since it is always rescaled to fit exactly within the camera frustum. So now you see frustum is a keyword that you usually don't use, so just open that up and check out what a frustum is. The size of the frustum at the given distance from the camera. A cross-section of the view frustum at a certain distance from the camera defines a rectangle in world space that frames the visible area. So if you scroll down a bit, you see that world space, for example, renders the UI as if it were a plane object in the scene. In our case, if it was a plane object some distance in front of a given camera. So in our case, the given camera is our main camera. So what we're basically doing is we're putting the canvas to be just in front of our main camera, because, well, we're defining our render camera to be the main camera. Okay, so if you look over here, basically this will be our canvas here with our background, in this case the image. Now inside of this, I would like to have a text. Okay, I would like to display a text. So let's go ahead and create a new UI object, and it will be text this time. I'm going to call this one word to find, because that's going to be the word that we want to find. And you can see it's pretty small. So let's change its size up. So the font size should be something like 100, for example. And at the same time, let's make sure that we set the width to 2000, so it will be pretty wide. And at the same time, the height to 150. So now you can see the text is pretty readable, I'd say. Now, of course, I would like this to be centered, so horizontally as well as vertically aligned towards the center. So if you scroll down in the text component, you will find the paragraph alignment, and here I want to use the centered version for both of them. So now the text will pretty much be in the middle of my screen, and for now it will say new text, but of course I want to change that, and I'm going to write a placeholder here because it will just say something like word to find, and later we're going to replace that, of course, with the word that we use in an array, and we're going to see what arrays are. So basically with the word that we want to use via code here. And now I would also like to change the position of the word to find. So this position Y, basically I want to move it down. So moving items or changing integers inside of Unity is something that you can either do by scrolling or dragging. You can see here I can now drag this item around. So this is one way to do it, and you can see the Unity, the mouse, it starts back at the position of the left hand side. So it's like Snake 2, where you would move from one side directly to the other side, basically looping through the screen, even if you have multiple screens as I do. So that's how you could move the position, but of course it's a lot easier to just enter a value if you don't want to do it by hand. So sometimes it's good enough, because sometimes you just want to see roughly like how things will look if you position them or reposition them a little bit without having to enter the value. But most of the times it's best to just enter the value directly. Okay, now what I would like to have is, I would like to have another text. So here, let me duplicate this word to find. You can either use Control D or Control C and V, or Command C and V, depending on which system you're using. So here I'm going to change this to win text. And now the win text should have a different position. So the Y position should be at 0, but the X position I'm going to set to -750. So towards the left. And I'm also going to change the width and height of it. So I'm going to change the width to 300 and height to 500, like so. Okay, so it should not say word to find. It should say something like you win. Okay, And also, of course, the text should be centered as you see here. So now we have this you win text. And if you want it to be nicely aligned, make sure that you don't have empty spaces anywhere. So now we have this you win text, and I would like to have the same for a you lose text. So let's duplicate this one as well. And I'm going to call this one lose text, like so. And it should say something like you lose. And what I'm going to do is I'm going to deactivate both of them. You can see here, you can untick them. So use this checkbox to uncheck it, and then the item will be gray in the hierarchy on the left hand side. So instead of being white, it will be gray now, which basically means that it's deactivated in the current view. It's not visible. So what we're going to do is if we win, we're going to activate the win text. If we lose, we're going to activate the lose text. So these are different ways how you can handle this. In the last chapter, you saw how we actively changed the text that was displayed. So we changed the text property of a given text item in our user interface. But in this case, what we're going to do is we're going to prepare the different items straight away and activate them or deactivate them. Okay, so this is just a different approach to achieve the same thing more or less, because in the end, they both will just display a way of, well, saying whether you won or lost. And now I would like to duplicate this once again, and I'm going to call this one time text. And this time text should display the time. So for now, the text should just say something like time. And let me activate it so that I actually see where it is. And I would like to change its position and set its position to -300 at this point. So here will be the timer, it will run, and let me change its height to 120 instead. It doesn't have to be as big because then they will overlap potentially. So you can see the time has a height of 120, the width of 30, and position of 750 minus, and same for the Y position, -300. All right. And that's it for this video. Always make sure to save your scene after you have made these changes, because otherwise everything will be lost. So don't forget that, and see you in the next video. Welcome back. In this video, we are going to set up our hangman as well as the stand at which is going to hang. So the idea is that we will make sure that all of his body parts are going to be deactivated so we don't see them. And then every time we make a mistake in terms of the letter that we selected, we are going to add one of those items. So for example, activating the head, then the body, then the right arm, left arm, and so forth. Okay, and that will not be done by us manually here, of course, but it will be done by our code. And yeah, this will allow us to learn a bunch of things about arrays and other parts of C# programming. So what you can see here is basically that we have a bunch of planes that we repositioned them, and we are using two different materials. So we have two different colors that we are using here. Feel free to build your own hangman with as many body parts as you like, or even entirely different objects that you would like to use that are hanging or whatever. But basically you can build the same thing as I did here, and I'd say let's get started building that in our game. And therefore what we will need is going to be 3D objects. In this case we're going to use quads. Okay, so a quad, if we look at the scene and we reposition this quad, we reset the position here first of all to 0, 0, 0. And now let's move this quad around, and let's actually move over to the quad. So you can see that you don't see it unless you are in front of it. So basically a quad is just a one-sided piece of wall, so to speak, but it's only visible from one side. Okay, so that's what this quad will do. It's not 3D, it's really just a 2D item inside of a 3D world, and we are going to use these quads in order to design our world. So let's position it at 0, 0, 0, and let's make sure that we change the color, because now we can't really see it. And if we want to change the color of an item, we are going to use something called materials, as we have seen before. Okay, so let's go ahead and create a folder first, and let's call this folder materials, because we always want to make sure that we have our items, our asset items, cleanly and tidied up. So here, let's now create a material, and I'm going to call this one Hangman. So this material will be Hangman, like so. And let me change its color to something grayish. Okay, like so. And then let's create another material in here. And this material will be wood. Okay, so I'm just going to use the wood material. And the color of that wood material would be a brown color. So you can select different kind of brown colors, the one that you like, whatever you want the wood to look like. So maybe such an orange brown or something like that. Okay, so now let's first of all take care of the hanging item. I'm going to call the first one base. Okay, and this will have the scale of, let's say, 3 times 0.7. And let's change the base's color by dragging this brown in there. Okay, so now you can, of course, move in here with your view. Okay, so this will be the base. If we look at the game, you can see that's where the base will be. And in this case, it's actually probably more useful to look at the game window instead of the scene window. All right, so now let's reposition the base. And you can, of course, play around with this Y value to move it around a little bit, like so. So hover with your mouse over the Y and then just move the item around. The same goes for the X value. So maybe you want to position it a little bit further to the right. Something like 4 will probably do the trick. And maybe the scale, the base should be a little bigger. So here it really depends how you want the item to look like. All right, now let's duplicate the base. And the next thing that I'm going to build is going to be the shaft. So let me rename this to shaft, like so. And let's change the scale of it. So the X scale, something like 0.7 maybe, and the Y scale, something like 6 or so. And then let's reposition it. The X should be at the position of the base. And now let's change the Y coordinate so that it's around like this, I would say. You can play around with the size here, the Y coordinate, so it really is up to you how you want to put those items together. Now, of course, you can also use it here. So you can, of course, in the scene view, drag your items around like so, if you feel like it, and also duplicate them from here. And of course, you need to make sure that you have the right item selected. So now let's say we add the pole, which would be this top part. So you can position this pole at the top here, like so. It can even be hanging a little bit like this. And the X scale should be a little bigger, maybe something like 5. The Y scale maybe should be a little thinner. So here, 0.5, for example. Okay, so this should do the trick. Then we have to add a support. So let me add that support in there as well. And the difference with the support will be is rotation. So let's drag it down a little bit and then let's rotate it like so. Something like this should be fine. And then let's change its size. And you can use the scale tool for that. You can see something like this, a little thinner. And then use the move tool again and move the item around. If you look at the game, you will see that it looks like one item, and maybe this item should be a little higher. So in the game view, you see it looks pretty good. Now we can add our board here at the bottom. So this one is not going to be the pole, but the support. Now let's duplicate our shaft and let's call this one cord. And we can reposition it like so. And change its scale, make it thinner. So 0.2 probably will be thin enough. And here the scale of 1 should be good enough. Let's position it a little higher like so. And then we can see we have it ready. Maybe we can even put it a little further towards the left-hand side like so, so that it's really hanging at the edge. So it really depends on how you want to put it. Okay, so this will be the basis for our Hangman game. Now, of course, we need to have the Hangman himself, and therefore we are going to use the other asset. Okay, so let me create a new 3D object in here, which will also be a quad. And this will be, for example, the head of our hangman. Okay, let's make sure we reposition it. So let's reset the position of our head and let's drag this gray material onto the head. And now, of course, we can play around with the values. So I'm going to position him just at the bottom of the chord. So here, let's put him up a little bit, like so. This should be fine. So the exact values will be different in your case. You can really just drag it around and position it as you want. So maybe we want it to be exactly at the center. So if that's the case, so if we want the hangman to be in the center of our game, it would of course make sense to change the chord position, as well as I believe it's the pole, right? This item here, we can change its X coordinate so it will be a little wider, and then change the chord to be at 0 for the X coordinate, like so. And I believe this will be fine. So now we have our head, and now let's create the other body parts for our good hangman. So here the body, and the body of course will basically be just a super thin head and a long head. So the X scale for the body should be something like 0.5 maybe, or 0.6 depending on how thick you want to make him, and the Y scale maybe 2.5 or so. Okay, so let's do that. They don't have to be really connected. It's fine if they are not. So this will then be the body. Now let's go ahead and create the legs. So left leg, for example, like so. And now, so I duplicated the body, by the way. And now let me move that around a little bit further to the bottom. We can of course rotate it, but of course you can also just add rotation values in here. So something that should work should be something around like 30 degrees, in this case minus 30 degrees. And then we need to change the scale a little bit. So let's make sure that this item, and you can select the scale tool here. So this leg is going to be a little thinner and a little less long. Okay, and then position it, and let's see how it's gonna look like. Okay, this is going to be the leg on the left hand side, and let's change it just a tiny bit, a little longer, like so. And now let's actually duplicate this item. So let's duplicate the left leg, let's call it right leg, and then just change the Z coordinate to 30 instead, and change the X coordinate to exactly the opposite of that. So not minus, but plus 0.65. This will put the leg on the right hand side. Looks a little stupid. Maybe the leg should be a little lower. So let's position both of them a little lower. Let's go over here. Let's go to the moving tool. And now let's change the Y coordinate up. So let's say 1 maybe, or even 0.8, something like this. Let's see. Now it looks like he's not even hanging, like he's standing on top of something. So 1 is still a little too high. Yeah, just play around with the values. Just find something that you like. 1.1 should be good. Something like this. It's fine. And then what you can do is you basically can copy your both legs and paste them in, and then position them a little higher, like in my case 2.5, like so. Now we have the legs, the arms. So arms and legs are looking very similar to each other. So this is totally fine. So it really depends on how you want to do it. As I said, I think this is fine. If you want to give him eyes, let's do that real quick. And by the way, let's rename those. So left arm, and this one will be right arm. And if you want to give him eyes, let's create another material here. Let's call it black. And let's make it black. So now he will have black eyes even. So you can add another head actually. So let's duplicate the head, and let's change the color of this head. Let's reposition it, and let's call it eye, or left eye. Left eye. And let's look here. So you can see now it's at the same position as the other item and we can't see it. So if we put it a little further to the front, then we will be able to see it. Okay, so now let's change its scale to something like 0.1 in all directions, and let's reposition the eye a little bit. So something like this. Maybe 0.1 is too small. 0.2 will be a little bigger eye, like so. You can see there is a shade. So here it really depends. Something like 0.01 should be enough, or minus 0.01 for the Z position of the left eye. And now duplicate the eye, call this right eye, and then you're golden. Okay, so the right eye, of course, will have the positive X position, like so. All right, and then we have the eyes. Now you could, of course, add a face and whatsoever. Okay, so you get the idea, I guess. So that's going to be it for this video. We have set up our Hangman. Make sure to save your scene because this was quite a lot of work to create all of these items that we now have in our project. And now maybe one thing that we could do is we could add those eyes to be part of the head. So drag them into the head, and then if we deactivate the head, the eyes will be deactivated as well. So let's see how that's going to work. You can see the eyes are disappearing as well because they are inside of the head and they are deactivated at the same time as they are children of the head. So your eyes are your head's children, so to speak. Okay, this is enough of a video in terms of its length and in terms of what we build. So this is how you can create super simple prototypes with no graphic knowledge at all. You can see even me as an absolute newbie when it comes to graphical items, this still works, and for a prototype it's enough. Okay, see you in the next video. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount, so don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, we are going to take care of our timer here at the bottom left, and we will implement it using code. So of course, we will need to create a new script if you want to use code, and therefore we're going to use Visual Studio once again. And I'd say, let's get started. So let's go ahead and first of all, create a new folder here inside of our assets folder. And I'm going to call this one scripts. Inside of the scripts folder, I'm going to create a new script because, well, that's what we want to do. We want to add a new behavior to our game. And I'm going to call this game controller. Okay, so this will be our controller that takes care of the game controller. And in this particular case, we're going to keep it simple. So we're really just going to have this one script that takes care of the mechanics of our game because there's really not that much going on in our game. So what's the goal of the script for now? Well, at least for this video, the goal is to display the time here. And in order to display the time and not just the text time as it does right now, if we look at our canvas here, we can find that we have this time text. What we want to do instead is we want to change this dynamically. So the text that will be displayed in our time text should be changed dynamically based on how long our game has been running, or basically a timer should run down. So these would be the different options that we have. So let's first of all create an object inside of our script that will take care of that. And I'm going to create a new object here, public text. And you might recall, if you want to use text, you need to use the Unity Engine UI namespace, like so, as we have done before. So now I can create a text object. So here a text variable, so to speak, and I'm going to call this one time field. So this will be our time field where we want to display our time. Now, in order to build a timer, we need to look at something called time.deltaTime. All right, so let's look at time.deltaTime. Time.deltaTime is a read-only float value that represents the interval in seconds from the last frame to the current one. So basically, every single frame a certain time has passed. And getting the time that has passed since the last frame can be received by using time.deltaTime. Delta basically means the difference, and what we want to get is the difference in time. So to be able to move something in a constant way, we always use time instead of frames, since depending on hardware, frames can change, but time will give us the same result. So for example, if you have a PC that makes your game run at 100 frames per second and you want to move an object at 100 meters per second, you would think of just moving it 1 meter each frame. But as soon as the same game drops frames, the speed of the object will decrease too, since it's linked to the FPS, so to the frames per second. That won't happen when using delta time, which is why we're going to do that. For instance, multiply speed by time.deltaTime and you will get exactly the distance moved by the object since the last update. So update was the method in our code. If we could look at it real quick, it's here and it is called every single frame. So once per frame, this update method will be called, which means the time between the update calls will be basically our delta time. And that will be the time that it takes for one frame to be displayed properly. So here you can see that these bars, for example, would be one update call. And then there is the time between the update calls, which would be, for example, a delta t of 0.1 seconds. So for in this particular case, let's say we have 10 frames per second, the game would be unplayable, but in 1 second we would have 10 frames. So it's better to actually make a game run based on delta time rather than on frames itself. So another example of time.deltaTime is to decrement or increment time at constant rates. So if you wanted to, like in our case here, to show elapsed time in a game, you would show it by using this. So by using the time.deltaTime. You can use time.deltaTime inside the update, inside of coroutines or fixed update. And Unity returns the time since the last fixed update in the case of using fixed update. So there are different kinds of update methods, for example, the fixed update, the update, and the late update. For now, we're just using the update method, but just be aware there is also this method called fixed update. We're going to use it later on and see what it does. And then late update, and we're going to see what that does also. And they have a certain advantage and really important to use as well, but we're going to use them later. But using fixed update is not a good option on UI because this function is called several times between frames. So now let's get into implementing this functionality. First of all, we'll need to have a variable that will take care of time. And this variable can be private because we don't want to set that variable outside of our script, but only use it inside of the script itself. And the variable type will be float, because time is something where you don't only have whole numbers, but you need to use floating point numbers, which is why we're using this data type float. And float can hold values such as 3.1, and you see we need to add the f here to indicate that this is a float. Otherwise, it would be considered as a double. So once you hover over here, you can see struct system double. Double is just a different type of floating point numbers, but it's more precise than float. But at the same time, it requires more space. Okay, so it will require more memory. That's why we're going to use float here. We don't need to use unnecessary memory. But of course, I don't want to set the time here when creating it, but I actually want to set the time inside of my update method. So here I need to use time plus equal time dot delta time. So what will happen here is time will take its older value that it had before, and it will add the time that has passed since the last frame. So here this time class, you can see class Unity Engine time, is also part of the Unity Engine framework, so we can use it in our project. And conveniently enough, it has a different color here as well. So it's this greenish color that it has. And then we can use dot and the property that we want to access. So here we are accessing a property called delta time. And that's exactly what we need. So the completion time in seconds since the last frame. So this could be, let's say we have 1 frame per second, then this would be 1. So delta time would return a value of 1. If we have 10 frames, then it will return 0.1. If we have 100 frames, it would return 0.01. Okay, so that's what delta time will give us, and we'll basically add it to our time variable that we have here. So this plus equal, let's look at that real quick. So let's say we had time plus 5 currently would give us 5. Okay, because time currently is empty, and if it's empty, by default in C#, it will have the value of 0. So we would calculate 0 plus 5, and that equals 5. When we run this the next time, our time will be 5. So time plus another 5 would, for example, be 10. Because at that point, time has been assigned the value of 5. And that's what this plus equal does. It basically just says, okay, whatever was the value that time had before, add whatever comes after this equal sign here. So in this case, the delta time value, which will also be a floating point number. So you can add floating point values to floating point values because our time is also a float. Okay. Okay, now let's save our script and let's go back to Unity. And inside of Unity, we will now need to create a new game object. So create empty. And I'm going to call this one game controller, like so. And this game controller, I'm going to reset its position because it's always good if your items are reset, if you don't need them to be at a specific spot. And then we're going to add a component. And the component that I want to add is going to be the game controller script. So you can search for game controller. That's the name of the script that we just created. So let's add that here. And you will see that now we have added the script. And at the same time, there is this time field that we need to assign. And it needs a text. So it says none, which means it's empty at this point. So what is going to be the item that we want to assign to it? Well, it's inside of our canvas. Because here we have our time text, this one. And we want to drag it into our game controller's time field. So what you can do is you can select it from here, just click on this dot here, and then select the time text. Or you can drag the time text, of course, from your hierarchy over into your inspector. Okay, at this point, if we run our game, nothing will happen, or there won't be much happening because we never actually changed this time field. But at least we have assigned it here to our Unity game controller script. So yeah, now let's go ahead and actually change our code so that it will display the time instead. Therefore, we get our time field now, and we can set the time field value, so its text property, to be the time. Now that unfortunately doesn't work. And if you were super careful, you will know why. And that is because this text here expects a string. So if we were to pass something like time, that would work. But unfortunately, that wouldn't really be the time. But we want to have the time value from our update property. So how can we get that in there? And well, basically we need to convert this floating point value into a string. So basically into a text. So instead of having, let's say 5.5, what we want to have is 5.5, like this, inside of quotation marks. Then it would be a string. So in order to get that, what we can use is time dot to string. So there is this method called toString, which in our case converts the float into a string, which basically means that it will convert our time value, our floating point value, into a text, which then can be assigned to the text of my time field. Okay, and this will be fine. So at this point, let's go ahead and save our script once again. Let's go back over to Unity, and now let's run our game once it's entirely loaded and imported. And we will see our timer is running. Okay, so in the next video, we're going to start preparing a hidden word by using a random word from an array. Therefore, we need to understand what arrays are. So see you in the next video where we're going to check that out. Welcome back. In this video, we're going to look at arrays, and we're going to require arrays in order to make sure that we can select a random word, which then will be populated in this word to find text. So instead of word to find, which is currently hard coded and is the word that we're looking for, we want this to be randomized, and it will be then selected from a list of words that we are going to create. And we're going to store them in one variable. And in order to store multiple values in one variable, we're going to use arrays. And that's why, well, this lecture is going to be about arrays. Let's get started looking at what arrays can do for us. Arrays are used to store multiple values in a single variable, instead of declaring separate variables for each value. Imagine, for example, for your grocery list, instead of getting a piece of paper for every item you need to buy, you would usually make, well, a list, a single piece of paper with several items. And arrays are basically that. Just declare a variable as you would with any other variable and add the squared brackets to it. And that'll tell C# that you want to use an array of the data type. So here you can see an example array. We have the private keyword, which indicates that this will be a variable that will only be usable within that same script. Then we have the data type string, and we have those squared brackets. So these are indicating that this variable called groceries should be an array of type string. And then after the equal sign, we're assigning the values that we want to assign to this groceries variable. And in order to assign values to an array, you can see you are using curly brackets here. So in this case, because we are using strings, we have to enter string items in here. So we cannot use different types of data in the same variable, in the same array. It always has to be the same data type. So in this case, we're defining it's going to be a string, so we cannot enter any numbers here. It has to be strings. And we separate the individual values that we want to have inside of this array by using the comma separator here. And of course, as always, we have the semicolon at the end. So to access the individual items in our array, we would need to access the specific position, or properly called index, and an array always starts counting at 0. Like in this case, milk has the index of 0. So if we want to access the milk, we would use the squared brackets 0. So that's going to give us the position of the milk. If you wanted the eggs, we would use the 2 here. So index 2. Let's see that in action and implement it into our game. Therefore, let's go back to our script. And here, let's go ahead and create a new variable that will be our words. And I'm going to create a private string. And here you can see I'm using the squared brackets, indicating that this variable will be an array. And then I give it a name. So I'm going to call this one words local, because this will be the words that I'm going to use, but they will be locally stored. And later on, you will see how to use words that will be coming from a text file. So they will not come from our code itself, but our code will read from a text file. Okay, and here I'm just going to have a couple of values in there. So I'm going to use the curly brackets and the semicolon afterwards. So this for now would be, for example, a string array with no values. But then let's assign a couple of values. For example, Matt. And then let's use Joanne. So I'm going to use names here. Then Robert. And then Mary. And let's say Mary Jane, like so. So you see, because I'm using strings, every single item inside of the array has to be a string. So you can see Matt is a string because we're using quotation marks. The same goes for Joanne, the same goes for Robert, and they are separated by a comma. So now if you were to use an integer array, what you would do is, well, you can add the access modifier, then use the int keyword, then the squared brackets, and let's call this my nums, so my numbers, and then again in curly brackets I would enter the numbers, so 3, 5, 7, 8, and so forth. Okay, and then of course at the end a semicolon. So now if I want to access individual items, what I will need to do is I'm going to need to access them by using their index. Okay, so let's use a debug log here just to see that real quick, and let's access our words local like so. So words local for now would display the field, the entire field, but if we want to access one particular item, we need to use the square brackets again, and here we need to say which item we want to have. So let's say using 0 will give me the first entry, because programming languages start counting at 0. So Matt is 0, Joanne is 1, Robert is 2, Mary Jane is 3. Okay, so let's save this script real quick and let's run it so that we can then see what will be displayed on our console. So let's run this real quick. And we can see it says Matt here. Okay, so it displayed Matt. Now instead, let's display index 2, which should give us Robert. Okay, let's save the script once again, go back to Unity, and once it's ready, let's run it. And we will see it says Robert. Now you can, of course, also assign values. So let's say I were to override it in my code. Let's say I were to override the second position here, like so, and saying Dennis instead. So instead of Robert, I would have Dennis in there at the index 2 position of my words local array. Let me save this script once again, go back to Unity, and let me run it. And you see it says Dennis instead. So now you saw how you can create such an array, how you can assign values to such an array. Here in this case, assign value to an array at a specific position or index. And this here is how you retrieve data. So access data from an array at a given index. So now a little challenge for you. Please make a calculation with my nums, with all of the values that are inside of my nums, but don't use any for loops or anything. If you are experienced already, just use the very basic approach as we've seen here to get the value, and then add all of them together and debug them onto the console. So display them using debug log onto the console as a result. Okay, so I hope you tried it. So basically what we will need is a new variable. I'm going to create an int result, which will be my nums 0 plus my nums 1 plus my nums 2 plus my nums 3. So here you have to be careful that you really only use as many items as you have created inside of your array, because otherwise you will run into an index out of bounds exception error. So now let's just display it onto the log. So let's use the result to display it like so. Okay, let's save the script and let's run it real quick. And you can see the result is 23. Well, let's double check. 3 plus 5 plus 7 plus 8 is 23, because that's 8 and this here is 15. 8 plus 15 is 23. Okay, so that's basically how you can use arrays. And you are not limited to simple data types such as strings or ints to use arrays. You can use any type of array. You can even use arrays for all types of data types, for texts, for floats, for strings. So you can see even this would be a data type, because every class can be used as a data type. Okay, so that's it for this video. In the next video, we're going to actually implement the functionality for our game. So let me get rid of the code that is not really part of the actual game, and words local will be the only one. So see you in the next video. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. Let's now use the array that we created last time in the last video and basically assign one of the values, a random one of those values, to be the word to find. So our word that we want to find, which now means, of course, that our game controller needs not only to use the time field, but it also needs to manipulate this word to find text. And you might recall how to do that. So please go ahead and at least create the variable for it inside of our script so that we can then assign our word to find text. So this one here at the top. So please go ahead and pause the video and try to create that variable. All right, I hope you did that and you paused the video. So basically we will need to do the same thing we did here, but this time it will be the word to find, and I'm going to call it field. Okay, so the word to find field, you could have called it word to find text or something like that. That would have been fine as well. It's just important that you're using the camel case that we're using here, as well as are making sure that you have a name that is descriptive. So at least it describes what we are talking about. So this will be the new line of code. Let's also directly make sure that we assign the text inside of our game, because otherwise we might forget it later on. And this happened to me while developing games quite often already, where I'm just starting the game and then I'm wondering, oh, why doesn't it work? Well, that's because I didn't assign a particular value to my script. So here, let's select the word to find text. So here, words to find field should get the word to find text. And now inside of our script, we can actually use it. But what we want to do is we want to basically make sure that we get one of those words here from the words local and assign it to be the word that will be displayed in word to find. But we want to hide it. So on one hand, we're going to store whatever was selected, and then we're also going to store the hidden word. So first of all, we have the chosen word. So what was the word that was chosen? And then we will have the hidden word. So the word that we are hiding behind it. They will be more or less the same, but they will serve different purposes, which is why we will use them. Okay, so let's say we want to assign to our chosen word a value. Well, we can do it like this, right? So we could assign something like butter here, for example. But of course, instead of assigning butter, we want to actually assign a random word out of the ones that we have here. So how can we do that? Well, let's say we do it like this. We access the words local and then we say, okay, give me the random one out of those. So random one, of course, doesn't exist. But what it does exist is a method that will give us a random value out of the ones that we have. And therefore, let's look at a presentation real quick. And by presentation, I mean a slide. Well, basically, it's just an image. But we're using the random action or a random class, so to speak. So there's this class random, and we're using its range method. And we're going to get a value between 0 and, in this case, 10. So between a minimum and a maximum. And this is basically the range that we're using. So we have seen that and we have used that in our last project, but I just wanted to emphasize on that once again, because we can do the same thing now in order to select a random index, which is exactly what we want. So now please pause the video and try to implement a random.range call here. Basically, we're calling the random.range method and pass values where you think that they would make sense. Okay, so I hope you paused the video. So we're going to use the random class once again. It's inside of Unity Engine, and we're going to use the range method. And here we need to pass two values, the minimum as well as the maximum. And the minimum should be 0, and the maximum, let's say, would be 4, because 4 is exclusive, which means the fourth value is going to be excluded. Why that is important is because if we entered 5 here, for example, in some cases our application would crash. So if the 4 would be included, we would have index 0, index 1, index 2, index 3, and there is no index 4. So if we are trying to access index 4, our program will crash. Let me actually show you that this is the case. So let me actually select the fourth value, which doesn't exist. Let me save the script real quick and let's run this in Unity. Okay, so once the script is loaded, let's run it in the start method. This is always a good moment to check something. You can see index out of range exception. And I mentioned this word in the last video really quickly, but I didn't show you. So in this video, we can see index was outside the bounds of the array. So whenever you get this error, you know that you are accessing an item of your array that does not exist. So that means that your array isn't that big, or it doesn't have as many items as the index that you are trying to access. So in our case, we only have 4 items and we're trying to access index 4. Well, 4 wouldn't be a problem if we had 5 items, because the index counts from 0. So it starts at 0, which is why we get this error. Okay, so let's fix this real quick and let's go back to our code. So we want to use random range, and here setting it to 4 is fine because, as I stated, it says the max is exclusive. So the 4 is not going to be part of it. The 3 will still be part of it. So it will give us a value between 0 and 3. Now that by itself is fine, but let's actually do something a little more programmy. So a little more advanced, because this is okay because we know exactly how many items we have here. But let's say we don't know how many items we have in an array, and we still would like to get the maximum item count that we have inside of this array. Then there is this property that any array has that we can use called length. Okay, so let me show you using the debug log like so. And I'm going to say amount of items inside of words local is, and then the item length. And this is something we can get by using words local dot, and you can see here there is this length property. And what that will do is it will return the amount of items that are inside of this array called words local. And now let's save this and let's go back to our Unity. And let's run the program, or the game in our case. And you see amount of items inside of words local is 4. All right, perfect. That's exactly what we wanted to know. So that we know that there are 4 items. So how does this help us with our range problem here? Well, the cool thing is we can just use this here instead. So we can, instead of using the 4, we can just use words local length. Because what that will now do is, no matter how many items we enter in here, it will just give us a random one out of those items that we have in our array. So if I were to add Dennis in here as well, so let's say I add Dennis now, and I save this, then words local.length will now be 5, which means that this will now give me a random item out of 5 items. So out of 0, 1, 2, 3, and 4. So out of the 5 first indexes, so to speak. Index starts at 0, as we know, and that's what this random range will give us. So now it will give me any of those 5 items. And you can even save the script and check it out in Unity once again to see how many items you now have, and you will see that it will now say 5 items. So words local is 5. So now we don't yet assign a text to our word to find field for now, but we're going to see how to do that correctly later on. Now, of course, we can go ahead and just say, okay, at the beginning of the game, we're going to assign word to find field, and we're assigning its text the chosen word, like so. Okay, so this will now give us the chosen word randomly out of those items. So let's save this real quick and go back to Unity and run the game. And you will see that each time we run it, so I ran it real quickly, it was Matt. So let me run it again. You see it's Dennis. Okay, let me run it again. It says Robert, and then let's run it again. Now it could be Robert or Dennis again. You see Robert once again. So that randomly was the case because we just have 5 values, right? So now it's Mary Jane and so forth. So now the value that will be selected, or the text, the name that will be selected for our Hangman game, will be randomized. That's exactly what we wanted to achieve. But now, of course, we want to hide it and make it a little more advanced, so to speak. So see you in the next video. Welcome back. In this video, we're going to look at loops, and particularly at for loops, because what we will need to do is we will need to replace the letters that we have inside of our word. In this case, if we run the game, we can see we have, for example, Dennis. We need to make sure that each of those letters is hidden, and then only once we have pressed the right button, for example, the letter will be displayed. Okay, so in order to achieve that, we need to look at what for loops are. So I'd say let's look at for loops first before we implement it into our project. Okay, so for loops. The for loop or for statement executes its containing code while a specified Boolean expression evaluates to true, usually going through an array, but it can also be used in other situations. So we can see here we are basically using this for loop, which will just write out the I value. So the for loop is structured in a particular way. Let's look at it. So we say that we want to use a loop, in this case the for loop. So this is the name of the loop type, and there are different loop types, and we're going to see later on how to use other loop types as well. So here we're using the for loop. Then we need to use the initializer. So basically the variable that will allow us to iterate and to basically count through our for loop, because the important part about loops is that they have a beginning and that they have an end. And then we have the condition. In this case, for example, the condition is that I is less than the word length. And then we have the iterator. So basically the number that will, in this case, increase by 1 after each iteration. So we're writing I++, which will basically increase the number by 1 after the first iteration, which means after the first execution of the for loop, then after the second iteration once again, so after the second execution, and so forth. And what this for loop will do is it will, for every single iteration, execute the code. So whatever is written inside of those curly brackets. Okay, so that will be the body of the for loop. This will be a lot easier to understand if we actually look at it in our project. So let's create a for loop inside of our start method. It will run once. Okay, so we have this for keyword, and you can see it has a specific color here, which means that it is a special keyword in C#. Then we have to have the initializer. So we're creating an integer, which for example starts at position 0. Then we have the condition. So for example, I is less than 5 would be the condition that we have here. And then we need to have the iterator. So in this case, the I++, which will increment our I after the iteration. So basically after the code has been executed once. And then inside of the curly brackets, that's where we have our code that we want to display. So let me just use a debug log here, and I'm just going to display I for now. And let me also get rid of this debug log here so that we don't get confused. And we of course need to add a semicolon here. So let me save this script and run it real quick. So here in Unity, run the code, and you will see it says 0, 1, 2, 3, 4. Okay, so what happened there? Well, if we go back to our code, we can see that first we started with int I equals 0. So in the first execution of our for loop, it was checking is 0 less than 5. If that's the case, so if 0 is less than 5, then please execute this code. And once you are done with that, please increment I. Incrementing means increase the value of I by 1. So let's check this out by itself. So let's stop Unity real quick. And now before we execute this for loop, so we can comment it out using this button here at the top. This will comment out all of the lines at once. So now let's use debug log in order to display a value. So let's create a variable real quick, int my num, and let's assign 0 to it. Okay, so now let's display my num in here, and what that will display is going to be 0. Now let's increment. So that is the keyword here, increment, meaning we're going to add ++ here. So what that will do is basically it will be the same thing as if I had written my num plus equal 1. So this here will do the same thing as that here. Okay, so this is incrementing, so increasing by 1. And then let's add another one. Call this one decrementing. This one will now decrement. And then let's display another one. And by the way, we can write something like decrementing. And here we can write something like incrementing plus and so forth. And here initial value plus. And here final value. Okay, let's save this and let's go back to Unity real quick. Okay, so there we are. Now let's run our game and we will see a couple of things. So first, the initial value is 0. Then it says incrementing 0. Then it says decrementing 1, and then it says final value 0. So what is going on here? Because I expected it to be the other way around. Or maybe you did. I didn't. I know that how it works, but maybe you did expect it. Because that's what would have been obvious. But let's look at our program here. And what we will see is that the ++ is after my num, which basically just means that it will use my num at this point and then it will increment it. So if we were to use my num the other way around, so let me write it like this, and then let me write another one down here and add the pluses at the beginning of my num. And before we run it, let's quickly also change what we write here. So incrementing ++ my num, and then that should be fine. Let's go back to Unity and let's run it. And it will say initial value 0, incrementing my num, it still is 0, incrementing my num, and now it's 2. So what happened here? Well, it was 0, and then we incremented just after we displayed it, because the ++ were after the variable name. But then we incremented ++ before the variable name, which means it was 1 after this line of code, so after this was executed, and then we increased it once again using the ++ before that, which added another 1, so now it's 2. Okay, so that's how it works. Then the decrementing thing is the same thing. So we had my num minus minus. So at the moment when the variable is displayed, it's still going to be 2, but then the line after it will be -1. So now it's going to decrement after this line here. So it will end up being 1, which means if we look at our code, it will be at this point. So here it will still be 0. At this point, it will be 1. And at this point of executing this line, it will become 2. So just after this line, it will be 1. And let me actually do it like this, next line. And then just before it executes this, it will become 2. And then it's decrementing. So in this line, it's still going to be 2. And just after the line, it will become 1. Because 2 minus 1 is 1. And by the way, you can use that same approach of plus plus for minus minus as well, of course. So here you are decrementing just before you are using it. So now it would display 1 at this point already. Okay, so this is incrementing and decrementing. And we're using it inside of a for loop. So this was just a little excursus. No worries, you're going to pretty much 99% of the times probably going to use this one here. So the other stuff was just for you to understand a little better if you ever see any other situation where the plus plus is used at the beginning or the minus minus is used at the beginning. So you know how these concepts work. Okay, so let me comment all of those out because we won't need them. And let's get back to our for loop. So basically we say the initial state is I is 0. Then we're comparing, is I, whatever value it has right now, less than 5? It's the case. Okay, so please run the code. Running the code, okay, I is 0. Then after the code is executed, increment by 1 or change the value with whatever you have here. So I plus plus, which now means in the next iteration, I will be 1. So in the second iteration, I is 1. So we're comparing, is 1 less than 5? That's the case. Okay, so this condition here is still met. So please go ahead and execute this code. Then after the code is done, increment by 1. So now I will be 2. Now compare 2 to 5. Is 2 less than 5? Yes, it is. Okay, run this code. Okay, done running the code. Please execute this here. So now I is 3. 3 less than 5? Yes, of course. Run the code. Then I is 4. 4 less than 5? Yes. So run the code. Then increase I once again. Now I is 5. Is 5 less than 5? No, it's not. So please stop running and don't execute this code anymore and go to the next line. So what we could do here is we could write done with the loop. Okay. So if we save this now and go back to Unity, and of course, we should always stop executing before we make changes to the code. But what you can see here, 0, 1, 2, 3, 4, and then it says done with the loop. Because at the moment that 4 was displayed, which means I is 4, in the next iteration, I would be 5, but this condition is not true anymore, which means this code will not be executed, which means that debug log 5 will never be displayed. So what's important with for loops is that this condition here should always be at one point not true anymore. So whatever we're doing here should stop this condition from being true in the future. That means that we don't want to have an infinite loop which will run all over the place and will never stop, because this would make our program crash. So if we were to use a statement here, let's say I greater equal 0, that would always be the case, because at the beginning it will be 0, so it will be equal 0, and then after that it will always be greater than 0. So this for loop that we have here is an infinite loop. This would never stop and it would make your program crash basically. So never have that. Always make sure that your for loop at one point will finish. So this part here is responsible of making sure that this for loop at one point will have an end and will not run anymore. And by the way, you can also count down. So let's say I is equal 10 and we're checking, is I greater than, for example, 0, then decrease or decrement I by 1 after each run. So let's save this real quick. Let's run it and it will count down. So let's see, 10, 9, 8, 7, 6, 5, and so forth, done with the loop. So we can also jump with 2 at the same time. So I minus equal 2. So this will now decrement by 2. Okay, so let's save this and run it again. So here, now it will start at 10, then it will be 8, 6, 4, 2. Okay, so that's how you can basically jump multiple steps at the same time, or multiple values. Okay, so this was a little bit of an introduction to for loops and to incrementing and decrementing. And yeah, let's go ahead and check out how to use this for our project to iterate through an array in the next video. All right, so now it's time to actually combine the knowledge that we acquired in the last couple of lectures, where we saw how we can get the amount of items that we have in an array, as you saw here, and where we saw how to use for loops. Okay, so what I want to do is I want to, for now, display all of the items one by one that I have inside of my words local array. So let's use the for loop. Int I equals 0 as the initial point, and then the condition should be, well, I is less than the amount of items that we have in our array. So you might recall how to do that. Think about it. Okay, I hope you paused or thought about it, and it's basically going to be this words local.length. So the amount of items that we have, because words local.length will give us, in our case, 5, because we have 5 items in there. So we're saying I less than 5. So as long as that's the case, I want to run my for loop. And then of course we need to add the I++ so that our for loop at one point will also finish. So now what I would like to do is I would like to display all of the items one by one, so line by line, using the debug log statement. So basically we want to access the words local at the position of our index, in this case of I. So I hope this wasn't too hard, but basically I is going to give us 0 in the first iteration, which will give us Matt. In the second iteration, I will be 1, which will give us Joanne. In the third iteration, it will be 2, so it will give us Robert, and so forth, until it gave us all of the names that we have in our words local array. Okay, so let's save this script, and let's go back to Unity to actually try this out and see what will be displayed on to our console. So there we are. It says Matt, Joanne, Robert, Mary Jane, and Dennis. So it gave us all of the names that we have in our array. So now you know how to iterate through an array and do something with every single item in that array. And now instead of doing that, what I would like to do is I would like to take the random word that I have selected and go through every single character that the word has. Okay, so that's also something we can do. We cannot just go through an array that has a bunch of words in it, a bunch of strings, for example. The same goes for integers or for floats or for any other type. And you might recall that there was this type called char. Okay, so let me comment this out as well. So here we had this type that was called char. So let's create a char and let's say it's a letter. And it will be the chosen word at the position I, for example. So like this, if we were in a for loop. So in this case, I'm just going to use 0. Okay, so let's actually print out the letter for now using the debug log and see what this will be. So let's print out letter. Let's save this. Let's go back to Unity. And let's run our game. And let's see, the first letter was R. You guess which name it is? Well, it's Robert. Okay, let's run it again. And this time it's Robert again. Okay, that's how randomizing works. Now it's Matt, and we see the first letter is M. So basically what you can see now is that a string is just an array of chars. So basically, let's say this string, Matt, is an array of 4 chars. So the first character is M, the second character is A, the third character is T, and the fourth character is T. So index 0 will be M, index 1 will be A, index 2 will be T, and index 3 will be T again. So what we just did with the array, we can also do with a string. So we can iterate through a string, in this case the chosen word, to display one character at a time, and for example replace it with a hidden letter or something like that. Okay, so let's create a for loop, and I'm just going to use this for loop that we had before, and I'm going to use the char letter. Instead of 0, where I define that it's hard-coded 0, I want to use I now. So what this for loop will do is it will basically go through the chosen word, whatever the word will be. For example, it would be Matt or Joanne or Robert. It will only be one of those at the time. So let's say it was Matt, and then it will iterate through the entire name, looking at each letter individually. Okay, so now, of course, for this to work properly, we need to make sure that we're not using words local.length, but actually the chosen word.length. So replace this with chosen word.length, because this way we get the length of the actual word. And what we can do here is we can also use debug log just to double check if this is working. So let's just display the letter for each iteration. So let's save this. And this is generally what I would recommend you do. Just use the debug log quite often to test and see if what you're trying to do is working. So you can see Robert is basically just a combination of chars of R-O-B-E-R-T. Okay, so that's what our for loop just did. It went through all of the letters. So what I want to do now, instead of using this debug log, is I want to check if my letter that I'm currently looking at is a white space or not, because we have this very special condition here where Mary Jane actually has a white space in her name, because Mary Jane is not a name that is just, well, one set of letters without a white space. So we have this white space and we have to treat it specially, well, in a special way, so to speak. Because what I would like to do is I would like to replace every single letter with an underscore. So let's just do that real quick before we do anything else. So here I'm going to say the hidden word, and you might recall the hidden word was this variable that we created, and I said it would be basically the same thing as the chosen word, but the chosen word is the actual word that was chosen, and the hidden word will be our replacement. So we're replacing the chosen word with the hidden word, so we are changing the way the word will look like. And what I'm going to do is I'm going to add a letter to it, and in this case I'm going to add an underscore to each of the positions. So instead of displaying, let's say, Matt, or displaying Robert or Dennis, I'm going to display for Matt, for example, 4 underscores. Okay, so now instead of displaying the chosen word, because that would be too easy, right, we're going to display the hidden word here in this line where we are defining what text should be displayed in word defined. And by the way, we're still in the start method. Okay, so in case you were wondering. So now let's save the script once again, and let's go over to Unity, where if we run the game now, we will see that we have a bunch of underscores. So each of those underscores is basically going to be a letter of the name that we're looking at. Now, this doesn't look very good because there is no space in between. We could, of course, add an empty space just after every single letter. Let's see how that's gonna look like. So this looks a little better, I believe. So we have letter 1, letter 2, letter 3, and letter 4. So this by itself is fine. And now we can run it with our Matt, with our Dennis, and so forth. But we cannot run it with Mary Jane. So how can we make sure that in case that it is an empty space or a white space, that we actually add just an empty space? So no underscore, because it's not really a letter. Well, there is this way of doing it, and it's called if. So we can always make a comparison. So if one thing is the case, let's do one kind of code. And if another thing is the case, let's do some other, or let's run some other kind of code. So here I'm just going to use char, which is the data type that we're using. And then it has a couple of methods that we can check here. And the one that I want to check is if it is white space. So is white space. So there's this method called is white space, and I just need to pass the character. So here you see char.isWhitespace requires a char called C. In this case, C is the variable that we're passing, and we're passing a letter to it. So we're looking at the letter that we are currently at inside of our chosen word, and we're checking if it is a white space, which means here in Mary Jane, the sixth letter will be a white space. The first one will be M, the second one A, then R, then R, then Y, and then we have this white space here. And in that case, I want to do something specific. I want to say that the hidden word should add just an empty space, like so. So this is an empty space, and here we have the underscore and then an empty space. So that means we need to add an else block in which I'm going to do this thing here, where I'm going to actually add the letter, which basically means an underscore in this case. Okay, so let's run this, or save this real quick and run it. And let's run it until we get Mary Jane. So this should be Matt probably. There we are. So we can see we have an extra empty space here, which indicates, okay, there is an empty space. So this would be Mary Jane. Okay, so let's go back to our code and maybe replace this with 2 empty spaces so it will look a little better. Actually, I think this will look a little better. Okay, that's fine. So now the hidden word will basically be our chosen word, but displayed in a different format. At least for now, I just wanted to display this to you in a nice format. Even though I would recommend that we really just get rid of those underscores, because it will make our life a little more complicated later on when we want to actually display the names correctly, or the individual letters after we have selected them. Okay, so the final stage should be that we're using an empty space in case the letter that we're looking at is a white space, and otherwise we're looking at an underscore. Okay, so that's it for this video. In the next one, we will finally see how we can get user input to actually play our game. So see you there. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount, so don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code, as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, we are going to implement the onGUI method and we will see what it is. So yeah, let's get into it. So for our game, we want something to happen only when the player pressed the button. So we don't really need any other case. So the perfect method for that would be the onGUI method. But what is this onGUI method? Let's look at that. All right, so the onGUI method. It is called for rendering and handling GUI events. GUI stands for Graphical User Interface. So on every user input, like for example our keystrokes, when the user clicks on a key or presses a key on his keyboard, we want to do something, and then an event is triggered and we can use that in our project. So every time a user input is sent through Unity, the onGUI method will be called. And with that, everything that your method body contains, so whatever you add into the onGUI method, here is where you would, for example, detect if the arrow keys or movement, or if the user just pressed a letter on his keyboard or not. Note that this is not by any means the only or the correct way of doing this. We already saw other ways of getting user input. It's just super convenient for our particular example. What is true is that in some cases the onGUI can be more of a solid option, especially if not missing a single keystroke is vital to your gameplay. A simple character movement doesn't usually need this, but you may find yourself developing a game where that fact is important, and since frame rate is something, jumping around a key press or two are missed could be a problem. While detecting in an update function can only detect key press during the current frame, onGUI can detect them independently and accurately, even queuing up button presses. But this can, depending on the case, cause a loss of frame rates, since there is the potential for it to be pretty heavy to run the method, depending on what you implement there. So it's really case dependent if you should use it or not. Like said, in our case, it will be great for convenience sake. So each onGUI call will give us an event, and this event basically gives us what it was that triggered the method. So what user input was given. The event contains everything related to the action, like its type, so if it's a key press, or for example, the exact key code. So if it was a letter, it would give us that specific letter. And also it will pass it through as an uppercase letter. That's actually why our words in our array have to be uppercase. Mostly for simplicity though. If you want, at the end, you could even try to implement a way to be able to use lowercase words as well. So this would be a little challenge for you. So to explain it with a direct example, let's say the user presses the letter M on their keyboard. That would then call our onGUI method, since a user input was passed in to Unity. Then the method would run its script body, passing through an event containing information on the user input. In this case, it being a key down type and the letter M. We can create an event type variable to store the current event for later use. That variable now contains all the passed through information, and we can now modify it. Read it and do whatever we want with it. As a final note, the event that the onUI method throws doesn't only contain these two pieces of data, it contains way more, like if it's the control key, if it's the shift key, if it even is a keyboard key, or maybe a mouse click. Most of the time we don't need all of those properties, but if you want to know more about every little detail, I would always recommend going to the Unity's documentation page. There you can find everything and maybe even try some of the other options. Some of them are really useful actually. So let's actually see how we can implement that in our game in the next video. Alright, so let's go ahead and use the onGUI method in our script. So let's implement it, and therefore I'm going to create a new entry here using onGUI. You can see that this method exists there in Unity, and we can just override it. So here it will be private void onGUI. So the method is going to be private, so only usable inside of our game controller script. It will not return anything, and it will be called onGUI. So this method will be called every single time that a GUI event happens, basically when we click on a letter, for example, or any key on our keyboard. So let's create an event, or let's get an event here, which will be event.current. So this will give us the current event that's being processed right now, which means the event that onGUI is currently processing. So E will now be our event. Event is another class inside of the Unity engine, and it has this property called current, which basically holds the current event. So now we have this method, and we would like to actually get a particular letter that the user has pressed. That can easily be done via conditions. We just need to check first if it's a key down event, since we want only key presses. Then if it's one letter long, since we only want a letter and we don't want to have the space, for example, so the space key on the keyboard or the enter key or any other symbols. So we can create an if statement first, and inside the parentheses we can check for the event type, and we can check if it is the event type key down, and if this is the case, then we can check the next step. So let's do that inside of onGUI. So we can check if E, this is the event that we have here, if it's type, so E has a property called type, it's the type of event. If it is of type event type, so there's this enum, and we're going to look into enums a little later. Now, just basically, an enum is going to be a list of values that are integers, but at the same time have a word assigned to them. Okay, so let's look at the event type enum. By the way, you can get to the screen here if you keep the control key pressed and then click on the event type, then this event type item will open up. And this counts for every class. So if you wanted to know more about, let's say, text, press the control key, click on text, and then you get to the text class. And you can find out more about the different properties as well as methods that this class has. It's a little confusing if you are not very familiar with programming, but in the event type, we can see a couple of things. So you can basically see here that mouse down has the event type of 0. So for the event type mouse down that we as humans would understand, the internal value is 0. Same goes for mouse up, internal value is 1. So the event type name is just something that helps us humans to understand what's up. Internally, it will be handled like numbers. But that's really the advantage of using the enums. And you can see that there are a bunch of different types of events. So mouse drag, key down, key up, scroll wheel, repaint, layout, drag update, and so forth. So what we are currently looking at is key down. So is it going to be the key down event? So what we could check here is the key type, the .key down event. So if that is the case, then I want to do something. So let me for now just debug it, and key down event was triggered. Okay, let's actually check this for now before we go any further. Let's save this. And now let's actually try to run this. So we can see key down event was triggered. So whatever key you're pressing, you can see the event is triggered twice in my case, and that is not necessarily what I want. The problem is that the key down event is one thing, but we also need to check if the events key code property. So this is the raw key code for keyboard events. And here we need to check if it is going to have just one entry. So what we're doing here is we are checking two if statements at the same time. First, we're checking if the event type is key down, and then we're using this double and sign in order to check another condition. So only if those both conditions are true, then whatever is inside of our if statement body will be executed. So the condition now consists of two conditions. So that means that we are checking if the key down is the event type, as well as the key code to string. So we make a string out of it first, so the letter that was pressed, and then we check for the length. So is it just one letter that was pressed? If that's the case, then key down was triggered. So let's save this once again and check it real quick. And now let's press a key, and we can see that now it works flawlessly. So how do we actually find out which letter was pressed? Well, we can use e.keycode to string for that. Okay, so this, as we used it here, will actually return the string of the key that we pressed. So let's actually display this here. So let's create a string that will give us the pressed key. And this will be our key code to string. And then actually, let's use that in order to display it. So key down event was triggered, and then it will say which key was pressed. So let me save that once again and run it. And now let me press a letter. And you can see now it displays the letters that I am pressing. So just make sure that you're inside of the game, because if you're in the Unity editor, things won't work, because the Unity editor also has a bunch of shortcuts. So you can see this tool here at the top is the Q key, then W is the shortcut for this feature, for the move tool, and so forth, right? So make sure that you're inside of the game, and then you can press those letters. So Q, W, E, and you can see each letter is now covered. All right, so what can we do with this? Well, what we can do with this now is we know which letter the user has pressed. And we can now compare if whatever the user has pressed, so the letter, exists in the context of our name that we are hiding. So in the context of the chosen word. And if that's the case, then we know that the user has selected the right letter. So here we can check if the chosen word contains the pressed letter, and in this case, the pressed key. So we could, of course, rename this, by the way, pressed key. Well, this is fine, but we actually want to only know which letter we are pressing. So let's rename this to pressed letter, like so. So right click and rename. And then it will rename all instances of where you used that variable. Okay, so we check if the chosen word now contains this pressed letter. So a string has this method called contains. And what contains will return will be a boolean. So it will return either true or false. So basically what this will do for us here, it will either return true or it will return false. And this is exactly what an if statement likes. It likes to know whether the condition here is true or false. And if it's true, then it will execute its code. Otherwise, it will execute the else block. So whatever is inside of here. So let's check this real quick in our start method. Okay, so let me actually check or create a string, my name, and let's call this Dennis. And now let's add a semicolon here. And now we can use this method, my name dot contains, and we can check if it contains, for example, a D. And if that is the case, then it will return true or false. So let me add an if statement here. If that is the case, then we want to debug log Dennis contains the letter, and else debug log doesn't contain the letter, like so. Okay, so here we're just checking, not user input, we're really just checking if my name contains this thing here. And you see we can pass not only a letter, we can actually pass a string. So we could even pass then, for example. Okay, so let's save this and actually run our game real quick. Okay, so you see Dennis contains the letter. So it says Dennis contains, well, it's not a letter, but it contains then, for example, right? So now if I were to use nis, it would also work. If I use isa, for example, let's run this. And you will see that it will not contain it. So does not contain the letter, even though it's not really a letter, but it's really another string. Okay, so now you know how you can get a letter from the keystrokes that were pressed. You can use the contains functionality in order to check if a string contains another string using the contains method. And now it's time to actually implement the logic behind it for our game. So this is just a preparation for what we will need to use in the next video. I'd say let's make a break here because otherwise the video would be too long. So see you in the next one. Welcome back. In this video, I would like to get to the point where we can actually select the letters and check if they exist in the context of our word, and then, well, basically change the word that will be displayed on the display. But I think we will need more than just one lecture for that, because first of all, I need to explain a new concept to you. And I'm going to go back to my start method, and I'm going to show you the concept of using the index of method. Okay, so here what I'm going to do is I'm going to use this chosen word that we have. I'm going to override it because it will be met in all of my cases now. And I can use chosen word index of, for example, a specific letter or even a string. So index of accepts a string that we can pass. So we can either pass t, or we can pass ma, or we can pass at, or tt, or whatever. Okay, we could even pass anything else, but it would give us different types of information. So what I want to do now is I want to see what kind of value I will receive. So int new val, so I'm going to call it, and I want to see what kind of value I'm getting if I'm using this method with my chosen word. So here I'm going to say new val is, and then the new val variable, like so. Okay, so let's see at which position inside of the chosen word the letter T will appear. And I can tell you it will appear at the position 2, at the index 2, because it only looks at the first entry, so to speak. So we can check that in our project now. So let's run our game. And we can see the new val is 2. Why is the new val 2? Well, as I just explained, the letter T is at the position 2 of my met string. So the string has 4 entries. At index 0 we have M, at index 1 we have A, and so forth. So you can check that using the M key. So let's run it again, and now it should give me the value 0. So you see, new val is 0. But what happens if the letter that we're comparing doesn't exist in the chosen word, or in the string that we are applying this index of method on? Well, let's check it out. So the S does not exist in the name met. So let's see what new val will end up being. All right, let's run it. And you will see new val is -1. So whenever a letter that we are checking, or a whole string, because this could have also been MA or whatever, or MAT, or even AT, like so. Whatever we're using here, if it doesn't exist in the string that we're comparing, so in this chosen word string, then new val, or the value that it will return, this index of method, because it returns an integer, will be -1. Otherwise, it will tell us at which position of the string this letter exists. And this is very useful, because that's exactly what we need in our Hangman game, because we need to know which letter the user pressed, and then we need to know how we can actually, well, which letter we should display on the screen. Okay, so that is the concept of the index of method. Next, I'd say we're going to look at while loops, because we've seen how to use for loops. Now let's look at while loops, because we're going to need them for the next part of the game. So I'd say let's have a little break here and see you in the next video. Welcome back. In this video, I would like to show you a while loop and how to use while loops. So while loops work a similar way like for loops do. So you use the keyword while, and then you have a condition inside of the brackets, the rounded brackets, and then you have your curly brackets in which you enter the code that should be executed. So what we can do here is, for example, while my value, let's create a new integer here, int counter equals 0, for example, while counter less than 5, use debug.log and display the counter variable, like so. And then make sure that the counter is going to be incremented. So basically, we need to make sure that the condition here is at one point not going to be true anymore. So that is a counter while loop that we're using here. So let's run this real quick, and this will basically display the counter here. Let me get rid of this debug log statement here as well, so that we don't have too many items that will be displayed in our console. So let's see. And you can see 0, 1, 2, 3, 4. Okay, so this while loop did the same thing as a for loop would do. So this while loop here transferred into a for loop would look like this: for int I, int less than 5, I plus plus. So, and then of course debug log, and here it would say I. Okay, so this for loop and this while loop, including this int counter, are basically doing the exact same thing. So that's one way of using a while loop. But why would you even go ahead and use a while loop? Well, the thing is, for these kind of counters, I would always recommend to use a for loop. But while loops have something else that they can do for you, because they don't have to have a counter. They can even do something as long as a specific condition isn't met, and this condition doesn't have to be a counter. So we're going to see an example of that in a minute. But for now, let's quickly recap how a while loop is structured. So you have the while keyword, then you have the condition, and then you have the curly brackets in which at one point you need to make sure that the condition here is not met anymore. This counter here at the top is basically a variable that we are using so that we can get the situation in our while loop that this condition is not met anymore, because otherwise we would have an infinite loop. So we're using this counter and we're incrementing it at this point, because if we would get rid of this line here, counter would never increment. So this while loop would be an infinite loop because this condition would always be met, and we would have an infinite amount of zeros being printed one after the other, one after the other. So that's why we need to make sure that the condition here, this one, is at one point not met anymore. But as I stated, there are other things that we can do with while loops. And that is, we can have conditions that are basically input related, for example. Okay, and that's what we're going to do inside of our onGUI here. Because I will get letters that the user has pressed by getting it from the key code. So whatever the user has pressed, we get the letter, and then we debug it, and we check if the letter that we pressed exists in the chosen word. But before we can use this, it's important to first of all understand substrings, which is what we're going to look at in the next video. Welcome back. In this video, I would like to explain you another concept that we're going to use in our game, and that is the concept of substrings. So inside of scripts, let me quickly create a new script, and I'm going to call this one basics. Okay, so let's add the script here and let's add that to our game controller. Okay, so I'm just going to drag it into our game controller. So the game controller will also have the basic script. You don't have to do that, but I'm just going to do that to demonstrate a couple of basics as I've done already, but I feel like maybe it's better to have it in a separate script. It will be less cluttered in comparison to our game controller, which is already, well, it has a lot of code already. So let's go ahead and assume a couple of things. So first of all, I'm going to have a new string, and I'm going to call this one my name, and it will be, let's say, Dennis. Okay, and now what we are going to look at is the substring method. Okay, so let's use a debug log like so, and use the substring method inside of that debug log. So I'm going to use my name dot substring. So you see, my name is a string, and the string class contains this method called substring. What the substring can do is it can either give you the substring starting from a start index, which is one overload, or it has another overload where you say after a certain letter, how many other letters do you want to have? Okay, so let's look at what this actually means, because otherwise this might be a little too confusing. So here, the substring, if you look at it, needs to have an integer int start index. Okay, so let's start at 0 for this particular example. Let's save this basic script, and let me check if I have any debugs inside of my start here. No, I don't. So this should not confuse us too much, because the game controller is pretty empty. So back in Unity, let me now run it real quick. So run my game once again. Go over to my console, and we see it says Dennis. So why does it say Dennis? Well, it's because if we look at our code, I want to have the substring of my name that starts at the index of 0. Now let's use 2 instead, for example. Okay, let's test this as well and see what we get as a result. It will be quite simple. We will get this. Okay, let's run it, and we say we get this. So why is that? Well, that is because now we say, give me the string that begins at the index of 2 for my name. As you recall, A string is basically an array of chars, so an array of characters. So here D will be index 0, E will be index 1, N will be index 2, I will be index 3, and S will be index 4. So N being index 2 is what we're using here. So what we're saying is, please give me the substring, so a part of the string of my name starting at the index of 2, which is why we get nis. Earlier we used 0 for the index here, so we got everything starting at the first letter, which gave us Dennis. If I used 4, for example, it would only give me S. Okay, so that is one overload of the substring method. And overload just means that there is one way the substring method can be used, but there is another way how the substring method can be used, and that is with the start index as well as the length. Okay, so now what I can do is I can say, give me a substring, so a part of the entire string of my name, whatever string is inside of it, in this case Dennis, that starts at 0, but only give me the length of 2 characters. So what this should give me is DE, because it starts at 0, which means at the D, and it includes the D, and then it gives me the length of 2 letters, so it will give me D and E. So that was what this substring method with 2 parameters can give us. So that's the other overload, so to speak. So start index, so where we want to start the new string, and how long we want the new string to be from the other string that we're comparing it to, or where we get the string from, the data from. So let's save this as well. And now let's run it real quick in Unity. Then it will make a little more sense. Actually, we'll get an error here because I let the program run in the background. So let's run it again. And as always, you have to, of course, earlier or before that, save your script. So I did that. And you see, I get DE here. DE, why? Because, well, the index 0 and a length of 2. So that is basically how a substring works. So Dennis will give me, well, this substring here will give me DE. Now, as a little challenge for you, change this code. You don't have to actually execute it, just think about it. How would you change this code if I told you, please give me the 2 last letters, in this case IS, of my name, so of the my name variable. Okay, I hope you tried it. So basically there are 2 ways of doing it. So either I say start at index 3, which will be this I, and it will give me the rest of it, or start at index of 3 and then give me 2 letters. So both of them will give me the same result. So if we had Dennis Panyuta here, like so, then this would be the only real result that would give me only this is. If I would just use 3 here, it would give me is Panyuta. Let's test this real quick and run it. And by the way, I would recommend that you just play around with this a little bit because we're using it in the next lecture, or we're going to use it, and you see is Panyuta. So that is the second way, or these are the 2 ways basically how you can use this substring method with 2 different overloads, one with just 1 parameter and the other one with 2 parameters. Okay, so let's use this concept in the next video. So see you there. Welcome back. Now that we have covered if statements, contains, so the contains method, the index of method, as well as while loops and the substring method, let's use all of that combined in order to add the logic to our game. Because the most difficult part about our game, at least from a developer's point of view, and especially as a beginner developer, is to actually check the word and then replace the empty word, so to speak, so the one that we are actually displaying, which will be a bunch of underscores, right? So replace the underscores with actual letters, and then at the same time also make sure that we are not reusing that letter once again, or what happens if we have the letter twice, and all of the good stuff. So it's actually quite complicated to set this logic up because there's a lot going on. we need to know about substrings. We need to make sure that the letter exists, and so we can use the contains method, as well as we need to know at which position the letter is, which means we can use the index of method. So, you know, this is how all of the things that we have covered in the last couple of videos are finally coming together in order to build the logic for our game. Because while it seems to be a very simple game, there is a lot going on. And that's why we chose this example to teach you all of these concepts and give you an idea of what you can do in programming and how basically a game can be entirely based around code. Even though we have a little bit of graphics, but really it's just getting rid of body parts or adding body parts to our visualization here. It's not more than just a counter actually, right? So this could have been just a counter, but of course a hangman is a lot more visual and more appealing to play the game then. So let's go ahead and actually adjust our code so that we will have the logic that will allow us to press a key as we have here. And then once that key was pressed, we check the key if it is inside of the chosen word. And then we need to check the position of that chosen word. Okay, so I'm just going to create an int I, which will be the chosen word dot index of. So I get the position of the pressed letter this way. So if the chosen word is in a specific position, then it will give us the index, right? So let's say we have the example that we had earlier where we have Dennis. If we press N, then at the third spot, so at index 2, we will have that. So I will be 2. So now what we can do is we can use a while loop to check if I is not equal -1. Why -1? Well, because if the letter does not exist in the chosen word, then we will basically get -1 here as the result, because index of will return -1 in case the letter does not exist. Because once we start this thing, it will exist. But then what we want to do is we want to iterate through it again. Because let's say we had the word Matt or the name Matt. The T exists twice. So we cannot just assume that every single word will only have letters once, but maybe this will be even the name Matt Titan, for example, because he's a real Titan. Then the T would even exist 4 times in here. So we have to run this check of the position where the T is multiple times, and we actually need to replace our current name that we are displaying, so our hidden word. So our hidden word currently looks like something like this, right? A bunch of underscores. Of course, it's a little more visual if I add the empty spaces, but basically it's just a bunch of underscores. That's how our hidden word right now looks. And what we want to do is, let's say we had internally the name Dennis, and we press the letter D, then we want to make sure that this one, or this letter here, will be replaced with the D. Okay, so this here is just what we pressed. This here is how the hidden word will now appear on our screen, so in the game. And of course, we need to then adjust also our chosen word. So let's say the chosen word at the beginning was Dennis, like so. And now that we have the D, we want to replace it with an underscore so that the D doesn't appear once again. So basically, once our chosen word is a bunch of underscores, our hidden word by default will be the final word, so to speak, and the player will have won. So that is the logic of our game, which means now these letters will also all have to become underscores. Okay, so that is what we want to achieve. And how do we achieve that? Well, every time that we press a button, what we need to do is we need to make sure that the button exists inside of the chosen word. And at the beginning, it will exist in the case that, well, the letter is the right letter. It will exist, and therefore, well, at the beginning, as I said, our chosen word will look something like this, for example, right? Okay, so let's assume we have that. Now, we check if the letter exists. Okay, it's in there, so this code will be started to execute. Then we check at which position does this exist. And then we have this while loop, which will run again and again and again and we're comparing, or we're saying, please run this while loop as long as I is not -1. So in order to get to the point where this is at one point not true anymore, so where I is in fact -1, we need to make sure that we check this again. So that we have this code in there again. And here we're not creating the int I, but we're just replacing I with the new chosen word index of. But this, as it is right now, would create an infinite loop, which basically means our program would crash, our game would crash. Actually, if you run this right now with this code, your Unity will crash and you will have to close it using the task manager, because otherwise you can't close it. It's not going to react at all. I tried it. It's fun. It's not fun. Don't try it. Or actually try it to just see it, okay? So then we have to make sure that the chosen word will in fact be overridden, because otherwise it will be an infinite loop. So how do we change the chosen word? Well, first of all, let's change the hidden word, because we now know that a letter exists inside of the chosen word, and we now need to replace the hidden word to display that accordingly. So in order to do that, we're going to use substrings. Okay, so here I'm going to use the hidden word. So I'm going to replace the hidden word with what the hidden word was before, but with the substring of 0 up until I, plus the pressed letter, plus the hidden word with the substring of what was after I. So I plus 1. Okay, so what's going on here? So basically what's happening here is we set the new hidden word to everything before the I, and change the I to the letter pressed and everything after the I. So that means, let's say we pressed N, okay? So our pressed letter will be N now. So what the substring here will do, it will give us everything from the beginning. So substring, as you recall, the first value that you enter is going to be where the substring will start. So here it will set the new hidden word to be __, because I is now, the pressed letter, which would be N, is now at position 2. So this would be the same as if we entered 2 here, in the case that we have entered the N key, because, well, the chosen word internally is Dennis, right? So the pressed letter exists in the chosen word Dennis at the 3rd spot. So meaning at index 2. So here, that's why we're using I, because we don't want it to only work for Dennis if we press N, but we want it to work for all situations. Okay, so here we have now our substring that goes from the beginning of the word all the way to the pressed letter. And then we replace the next letter with the pressed letter. So here, this means that this will be the first 2 entries, because it just says where was the pressed letter in comparison to the beginning of the word, and the pressed letter was, as I said, at index 2, which means we will go 2 letters far, so 2 underscores. Then we will have the N, the pressed letter, because that was the letter that we pressed, the N, and then we will have the hidden word with the substring, which will give us everything past I plus 1. So which will give us everything past 2 plus 1, which means the index 3. Index 3 is I and S. So actually index 3 is I. And everything past index 3 will be this underscore and this underscore. So basically it will be like so. So after this iteration, this is what we will get if we press the N key, because the N key exists inside of the chosen word, because we're comparing the chosen word here with indexed letters. Okay, and after that is done, we are checking the chosen word again. Oh, wait, we didn't change the chosen word, we only changed the hidden word. So now let's also make sure that the chosen word now doesn't say Dennis anymore, but it says DE underscore IS. Okay, how can we do that? Well, basically we do a very similar thing that we did here with the substrings, but we do it now for our chosen word. So let's set our chosen word to be chosen word with a substring of from the beginning all the way up to I, and then replace it with an underscore. So at the point where we had the pressed letter, so to speak, and then take the rest of the chosen word, so to speak. So here substring, and then 0, well, actually I plus 1. So basically we're doing the same thing, only that the hidden word will step by step be replaced with the letters that we have pressed, and the chosen word will step by step be replaced with underscores. Okay, as we see here. So N was pressed, now the hidden word has the N, but the chosen word doesn't have the N anymore. So now we're checking again, is the pressed letter, which was N, is it inside of our chosen word, and what is the index of it? Because it doesn't exist anymore. So you can see here at this point, the chosen word doesn't have the N anymore. So this method here will return -1 in this particular case. So then this while loop will check, is I not equal -1? And this statement will then be false because I is equal -1, which means this while loop will not run again. It will then go to the next line. So what we need to make sure of is that the word to find field text will now be the new hidden word, like so. So that is a lot that goes on here. So let's actually test this. And we have the chosen word. We are hard coding it at this point with met. Okay, so that means we should have the M letter inside of our game. So let's go ahead and test if the M will appear if we run our game. And then if the T will appear, and it appeared twice, because the T is the more difficult one, because it had to appear twice. So let me press T, and you can see T appears twice. Let me press M, and the M appears, and A, and we have our met. Okay, and now let's actually run it again, but this time without hard coding what kind of name it was. So now it will be a random name out of those ones here: Matt, Joanne, Robert, Mary Jane, and Dennis. And before we actually test it, let's make it easier for us as the developers by making sure that we are debug logging the hidden word and that we are debug logging the chosen word, so that we as a developer can see what's up. Okay, so now we have to make sure the chosen word will be selected randomly. That's fine. And then let's actually save the script. And let's check out our console, because there will be a lot going on. So let's play the game. And well, we have this Españuta. Then let me see the P. Well, it doesn't exist anywhere. Let me add the T. Okay, so we can see I added the T. I pressed the T. And you can see that it says here, key was triggered T. Okay, then it displayed the T. So underscore underscore T underscore, which is our hidden word. So the T exists now. Then in the next second or millisecond, just the next code execution, so to speak, was to change our internal word, so the one that we are searching for, from met with 2 T's to MA underscore T. And then it added the second T, this one here, and it made sure that it got rid of the second T in our chosen word. Okay, so if you look at it, our hidden and our chosen word are now set up correctly. So we are replacing the hidden word step by step with all the letters that the player has pressed and that are inside of our chosen word. And we get rid of them from the chosen word so that they will not appear once again. And basically this is how we can build the entire logic of our game. All right, so that was, I'd say, the most difficult part of our entire game. And well, along the way, you learned a bunch of features about strings, actually. So the index of method, the substring method, then the contains method. But at the same time, you learned if statements, while statements, then also how to use, the events here with the key codes and a lot more. So let's go ahead and add the logic for our Hangman, because we also need to add the logic that our game will eventually be won or lost. So see you in the next video. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone and optimize it for mobile and export it for mobile as well, how to build a first-person shooter game, and finally how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. All right, now it's time to actually make our game winnable and losable. So when is the game lost? Well, the game is lost once the hangman is entirely hanging. So that means we need to make sure that our hangman is actually not going to be entirely in the game until we have added him to the game. And it's going to be quite easy to add him to the game. Basically, we will need to activate all of those items. So the head, the body, the leg, and so forth. We need to add them step by step. And once we have added them, and he's entirely there, so to speak, and there are no other parts that we can add to the hangman, at that point the game will be lost. So how can we win the game? Well, winning the game is basically just entering the right word. So pressing the right letters before the hangman is fully hanging. So basically, if we look at how many body parts the hangman has, we have 6 tries. And after 6 wrong tries, we have lost. But if we came up with a word that we are searching for, in this case, the name that we're searching for, then we will have won. Okay, so let's add the logic for that. Therefore, let's make sure that we deactivate all of those body parts. So press each one of them and make sure to deselect it. You can also press multiple ones at the same time, like so, using the shift key. So hold the shift key and then select all the items and then activate them or deactivate them all at once. That's another way. You don't have to do it one by one. And once that is done, you can go over to the code because that's where we are going to implement the logic. So when are we wrong? Well, we are wrong each time that the chosen word doesn't contain the pressed letter. So at that time, we need to make sure that we add the logic to losing the game, so to speak. So here, add a hangman body part. Okay, so that's what we want to do here. But we need to know where the hangman is because we don't have the hangman yet. So let's actually add the hangman to our game. In order to do that, we can just go ahead and create a new game object. So public game object, and it will be an array of game objects. And in this case, I'm going to call this one hangman. So it's an array of game objects. Okay, what is an array of game objects? Well, it's the same thing as an array of strings, but now instead of storing string items inside of this array, I'm going to store game objects inside of this array. So the game objects are basically objects inside of the hierarchy of our game. So let's save this script real quick and go over to Unity just to see how this impacts the appearance of our game in the sense of our game controller. So if you look at the game controller, now you have this hangman here, and you can define how many items you want to have in there. So how many body parts does our hangman have? Well, it has 6, or he has 6. So let's add 6 in here and press enter. And then this will give us 6 elements here. So now we can drag the body parts in here. So I'm going to start with the head. I want the head to be the first item that will be added. Then the second one will be the body. Then I'm going to add, well, actually, let me add the left arm. So game controller, let me select it from here. You can see that if you select game objects from the scene, these are the game objects that you have. So basically everything that we have in the hierarchy, every single game object item is an own game object. So we could even add the pole to the hangman. the pole items. So basically like the items of our construction here. But of course, I only want to have body parts of our hangman in there. So let's go with the left arm for element 2. For element 3, I'm going to select the right arm. So this one here. Then for element 4, I'm going to select the left leg. And then finally for element 5, the right leg. Of course, you could have also dragged them in there. Okay, so now we have these 6 items inside of our hangman, and what we need to do is each time that we made a mistake or that we entered a letter that is not inside of the chosen word that we're looking for, we need to activate one of those items. So for example, first we want to activate the head, then we want to activate the body, and so forth. But we don't want to do it manually in Unity, but we actually want to trigger this via code. So now we have our hangman, and let's actually add the hangman body parts one by one in here. So how can we do that? Well, basically what we can do is we can say that our hangman should be set to active. And there's this method called set active, and we set that to true. But to which item are we setting that to true? Because the hangman is actually an array of game objects. And the game object isn't happy about this set active because, well, actually we are talking about an array here. So now you can see set active is happy now. This method exists, so it's fine. But now it needs to know at which position we want the hangman should be activated. So which body part should be activated. Therefore, we need to have another variable that will take care of that. And that variable will be another integer that I'm going to create. So private int, and I'm going to call this one fails. So this integer will store how many fails we had. So how many wrong letters we have pressed, so to speak. And by default, by the way, in C#, this will be 0. Okay, so we don't have to define this being 0. By default in C#, an integer, if you create it, once you create it, it has the internal value of 0. So fails will be at 0. And now we can just say set active at the position of fails. And now, of course, we also need to make sure that we increment fails so that the next time we fail, that we will activate the next item inside of our hangman game object. So here our hangman game object array has a bunch of items. So let's save this real quick and let's test it actually. Press run, and now, okay, I pressed the S key, and as you see, the S key is not in the name here. So I pressed the E key, now E exists. Now I pressed the Q key here, and you see Q doesn't exist, so the next body part is added. The T exists, Robert, well, I'm too good at this game, so I know that G doesn't exist. Let me press G once again, and G once again, and well, now you see all of the body parts are there. And at this point, what we actually want to do is we want to lose the game. Okay, so now I'm pressing, and you see here index was outside of the bounds of the array. So we're trying to access something that doesn't exist. So this is not good. We need to fix that because this is basically a bug that we are creating here. And how can we fix that bug? Well, basically we know that once the entire body is there and every part of it is active, we need to make sure that the game is lost. So let's make sure that the game is actually lost. Therefore, let's actually also add our other game objects that we want to activate. We can just say game object win text. And now let's do the same thing for our lose text. Okay, so we have those two texts. Let's add those two. And what we want to do is we want to activate the win text if we won and the lose text if we lost. Okay, so let's add those to our game. And let's actually make sure that in Unity, we also have defined them or assigned them. So here you can go over to your game controller, and now you can see you can define the win text and the lose text. So at least you can assign them here. So what will be the win text and the lose text? You see, because I selected this as a game object and not as a text, of course it will give me all of the potential game objects that I could show. But I'm going to use the win text here for my win text and the lose text for my lose text. And now let's actually make sure that we can lose the game, because we have assigned win text now, but we're never actually displaying it. same goes for loose text. We are not displaying them. And when will we have lost the game? Well, if the letter that we typed is not in there, so basically our fails here are greater than the amount of body parts the Hangman has. And how many body parts does the Hangman have? Well, we can find it out by using the Hangman.length property. So this will give us the amount of items that the Hangman has. So how can we actually use this now efficiently? Well, we can just check if the amount of fails is equal to the length of the Hangman, then we know that we have lost. So what shall we do at this point? Well, first of all, we want to set the loose text active. So we want to activate the loose text. And at the same time, we want to create a state where the game is lost. So we will need to have a variable at the very top that will know whether the game is running or not. And we can do that by using private bool game end. Okay, so this bool will only have two possible options. So it's either true or it's false. So what we can say at the beginning straight away, that by default, this will be false. So the game will not have ended, so we won't have lost once we start the game. But we can manipulate this variable and set it to true once the game is actually ended. And when is the game ended? Either when we have lost or when we have won. So let's add those two cases. So first of all, we have the lose option, right? Here we have lost, and we make sure that the game end is set to true. And now let's add the case, so case lost game. Now let's add the case won game. So case won game. And we won the game if, so when do we have won the game? So think about it. Maybe you want to try this yourself and add the code in here. Maybe you want to pause the video and think about it. I can tell you it has to do something with the hidden word. So you can just check if the hidden word has a specific character. I'm going to give you a hint, hovering over it. All right, so let's check it. In here, what we need to do is we need to check, is the hidden word going to contain any underscores? And if that's not the case, so we add this exclamation mark at the beginning. This is the same as if I were to say not equal true, or if I were to say equals false. So adding, so equal, adding the exclamation mark replaces this part here. So we don't need to add this equal false there. So basically it does the same thing. So what do we want to do then? Well, first of all, we want to make sure that the game end is also set to true because we have won the game. And we want to make sure that the win text will be displayed. So we want to activate the win text by setting it to true. So this basically, this set active true, by the way, you might have understood it already, but just to make sure, it's just doing the following thing. It goes to this win text, for example, and checks this tick box. Okay, so it says you win, for example. So what is it that we else need to do? Because that's not it. We also need to make sure that we are actually stopping the game at this point. So let me go over to my update method. And in my update method, I need to check if the game is running, because I only want to make my timer run brr and go brr if the game is still running. So if the game end is false, then I want to make the timer run. Otherwise, I'm going to stop running or making the timer run, and basically it will stop at one point. So let's save this script and let's actually test our game. So let me press a letter. And D was pressed, I was wrong. Okay, E is there. So you see, okay, I know it's Joanne. So let me enter Joanne and win the game. And you see, we won the game in 14 seconds. But the body parts that we added were 3. So now let's actually lose the game. So let's run the game once again. And let's add couple of wrong body parts, and you see I lost the game in 4.72 seconds. All right, so that's basically the game logic that we have. Our game, it does work, but of course, we would also need to find a way to restart the game once we lost the game. So this could also be something that we will need to add if we wanted to make this game rerunnable. But for now, for testing purposes, it does the trick. Also, make sure that you are saving your game scene. Otherwise, your project might be lost. All right, so that's it for this video. In the next video, you are going to see how you can use the file system. So basically, how you can get the names or the words that should be part of your game from a Word file or a text file, so to speak, instead of having it hard-coded into your game. All right, so see you in the next video. Quick pause. The video that you're currently watching is just a fraction of the entire course that I have to offer. So I built this complete Unity Masterclass course in which you're going to learn how to build real games and how to build them from scratch. So you're going to learn how to build a platformer game, how to build a Space Invaders clone, how to build a Fruit Ninjas clone, and optimize it for mobile and export it for mobile as well. How to build a first-person shooter game. And finally, how to build a tycoon game similar to Adventurist, which is an endless game. So if you want to become a real game developer, definitely check out the course. You can find the link in the description and you will get the course with a huge discount. So don't hesitate, as you will not only get the course, but you will also get it in a structured manner with all of the code, as well as a Q&A section with a 5-star support. So get the course now. I hope to see you there. Welcome back. In this video, we're going to look at the file system and at how we can use a text file, for example, to get data from that file in order to use it in our game. Because what we have so far is that we hard-coded the names or the words that will appear in our Hangman game and that will be, well, selected from. But what we actually want to do is we want to make sure that our game is more flexible. So let's say we have a text file which anyone can edit. They don't have to go into the code or anything. They can just go ahead and edit the text file and run the game, and the game will basically use the words from the text file. And that is what we want to achieve in this video. Therefore, let's go ahead and create a new text file in our project. Therefore, what I'm going to do is I'm just going to show this folder in the Explorer, and here I can go ahead and just create a new text document like so. And I'm going to call this one words.txt. Now let's go over into this words.txt file and let's change it a little bit. So for example, I'm just going to put those names in here and each line by line. Okay, so every name or every word that you want to use is going to have a different line. Boris would be another one, or whatever you want to come up with, right? So feel free to add as many names as you want. Make sure that you don't have an empty space afterward, and that should be it. So save this file. And by the way, you can also edit the file directly using Unity / using our Visual Studio, because you can see here, you can also open text files from here. All right, so now you can make the changes that you want to the text file. And now let's actually look at how we can use it in our game, because what we want is we want to basically replace this words local with our words text file, which is going to be the external file, so to speak. All right, so let's look at files in Unity. So what is the file or file system? Well, it's a method to interact with files on your system based on the namespace called system.io. So it provides static methods for the creation, copying, deletion, moving, and opening of a single file, and aids in the creation of file stream objects. The file system has a ton of uses with equally as many methods. There's a lot, like reading, writing, deleting, moving, encrypting, decrypting. I mean, just visit the documentation and look at them. They're endless. Today, though, we only want one. And we are going to specifically look at this read all lines. You see that one that is animating there? That's the one that we're going to use. Because we want to read all the lines once the game is started, and then just display those inside of our game. And then basically select a random name or word from this text file. So let's go ahead and first of all, create a new private string that I'm going to call words. Okay, not words local, but actual words. And here we can use the file class, and the file class only exists inside of this namespace that we need to add. So using system.io, and IO stands for input output. And we're getting the input from a file. So basically we're getting it, you see here, once we hover over it, system.io.file. File is a type which is not valid in the given context. Well, that's because we are not reading all lines. So we can just use this read all lines. And now we just need to say from which folder we want to get the files. And in my case, it's inside of my assets folder. So here I have to call or use the @ sign, and then assets with a capital A, assets slash, and in my case, it was words.txt, and then finish the statement with a semicolon. So you can see here, we now get the words from a file called words.txt, and make sure that this is exactly how you named your file. So in my case, I called it words.txt. And now it will read all the lines and it will store them inside of this words string once our game starts. And now we can use those words instead of the words local. So it's going to basically do the same thing. We just use words and words length. So here we replace words local with words, and here we have to do the same thing, otherwise our game might crash. So now the chosen word will basically be retrieved from the words list, and it will randomly take one of those. And the rest can stay pretty much the same. So there's really not that much of a change. Let's actually even get rid of this words local. Let's comment it out. And now let's save our script and see if our game is still going to work. Because now we are actually using this external file. And by the way, this file needs to be inside of the assets folder. So if you were to create an extra folder for, let's say, Word documents or text files, then you would drag it, let's say you drag it in here inside of text, then you would have to change the code accordingly. So now you need to go ahead and change the folder here. And let's say I added it to texts/words. Okay, so let's check. It's texts exactly as I wrote it. And then this should work as well. So always make sure that the folder is exactly correct. We're using the @ annotation, basically saying, okay, this is where it's going to be. And it's inside of the assets folder of the current project. So Unity knows it straight away. It's going to take it from that particular path. So this is the directory, so the path where your file is going to come from. All right, so let's go back to Unity and actually see if our game is going to crash or not. And I hope it won't, because it should still do the trick. So I guess this is met. All right, and you see it's still working. All right, now let's try it again and see what the word is. And let me go over here and into the game R. Okay, so it's Robert. All right, Robert, and we won. All right, so that's it for this video. Now you know how you can use the file system to get data from the file system. It's super useful. You could, of course, now also use this in order to save the records, for example. So save them and store them inside of a file. That would be an option, and a lot more. But we're not going to do it with this game. We're going to do it later on and see how we can save high scores long term. And then also what we still need to do is we need to find a way to also be able to restart the game. Because if you look at it, we don't have a way to restart the game even if we won the game. So that's what we're going to look at in the next video. So see you there. Welcome back. In this video, we are going to add the functionality to make our game replayable. So basically we can do that by just reloading our entire scene. So in order to do that, we need to have a way to trigger this event. And we could, of course, say, okay, after the game has been won, we reset the game straight away. But it would be nicer if the player can do that himself. So if the player can press on a button and then reset the game. So let's go ahead and create a new button like so. And I'm going to say replay, or I'm going to call this one replay button, something like that. Now let's go over and change its position and its size and all of that, because currently you see it's pretty small. So let me actually make it something like 500 times 200 or so, and the button should be positioned, well, let's see, what can we position it? Maybe in the top left corner. Well, we can actually leave it in the center. It will be pretty big and it will be very visible. So let's also change the text size here a little bit. So 100 as the font size should be good to go. Now the text should say something like replay. Okay, I'm not going to care about making it nice or anything. I'm just going to keep it super simple. So this button, let me actually position the button at 0, 0, like so. It will be directly in the center of our game. And let's also make sure that this button will be invisible all the way until the point where we actually won the game, and it has to become visible. So in order for this to work, we need to make sure that we put it into our code as well. All right, and now let's go ahead and use public game object, because we want our button to be a game object so that we can make it active or activate it and deactivate it. So I'm going to call this one replay button. And now let's actually use this replay button at the point where it makes sense. And it makes sense when we won the game or we lost the game. So here, let's say replay button, set active, and let's activate that using this method. And we're going to do the same thing in the case that we won the game. Okay, so we're going to activate it, and that will basically do the trick. Okay, now let's also make sure that we actually assign this to our game controller script. So let's assign the replay button here at the right hand side, and I'm going to search for replay button like so, and I'm going to assign the replay button here. So let's actually see if the replay button will appear once we lost the game, and we can see the button appears. So we could either change the Z position of the button, or what we can also do is we can actually just move it over to the top left corner or the bottom right or something like that. So let's do that real quick. So here, replay button, let me change its position. Let me make it visible first, and then actually in the scene here, let me select the moving tool. So this one here, you can also press the W key. And let's position it at the top left corner, somewhere around here. So maybe 750 in the negative for the X position, and the Y position of 400. Then it will be always at the same spot. Very nice. At this point, it should be good to go. Okay, so let's run it again. And actually, let's make sure that it's deactivated. And now let's run it again and see how it's going to look like if we lost the game. All right, there we are. And now we want to make this button clickable. So let's give it a script that will actually reset the game. Therefore, we can create a new script here. And I'm going to call this one button controller. And let's go over to the button controller. Double click. All right, and now let's create a method in here. So it's public void, it will not return anything, on button click. That's how I'm going to call it. Basically, once we click on the button, what is it that we want to do? Well, we want to reset the scene. So basically, we want to load the scene once again. That's another way of saying reset the scene. So what is the scene? Well, let's go over to Unity and check it out real quick. So our scene is the game scene. Let me save the game scene because I had this little star there. What I want to happen is I want to make sure that I set the state of the game scene to the state that it is right now when I press the run button. So exactly that state, which means the timer is at 0 and the word is selected randomly and everything else is reset. So how can I do that? Well, therefore, let's look at something that you will find under build settings. So here you can add the open scene, for example. So the scenes game scene. All right. So now inside of scenes in the folder, there is the game scene, and it has this 0 here at the end. So the 0 is the ID of the scene. So if you have multiple scenes in your game, for example, multiple levels and stuff like that, then you would have different IDs or indexes for each of those scenes. So our game scene now has the index of 0. So we just need to make sure that we load the scene that has the index of 0. And we can do that in our button controller code in here. Therefore, we need to use the scene manager. So scene manager. So if you want to use the scene manager, you need to add the following namespace. So using Unity Engine dot scene management. So there is this namespace called scene management, and we need to use that in order to access the scene manager, which now allows us to load a particular scene. So you can now load the scene, and there are two different ways of loading the scene, or multiple different ways. So if you hover over it, you can see there are 5 overloads. So there are a bunch of different ways to load the scene. So what I just want to do is, I just want to load the scene 0. What that will do is, it will load my scene at the position 0, as we saw just now when we went to the build settings here. Okay, after I added the open scene, that is the scene that is currently open. The alternative way of actually loading the scene would be just to say the name of the scene. So I could also just say load the game scene, because that was the name of the scene that we want to load. So let me save that. And now, as a little challenge for you, make sure that once we click on the button, this method will actually be called. So try that. Okay, so I hope you tried it. And what I'm going to do is, I'm going to add the button controller script to my button. That will be one thing, like so, adding that. And then I'm going to add a click here in the button. So inside of the inspector of my replay button, I'm going to add it. And here, I'm actually going to select the button itself as the object, because the button, the replay button, has a script called button controller. And this button controller script now has this on button click, which basically is just this button controller script that we created. And there we have this button method, so this on button click method, that will basically just load the current scene, or load the game scene once again using the scene manager. So we're using the load scene method, which then loads the game scene, and that is exactly the name that we have used for our scene name. So here, this one, exactly that same name, otherwise it wouldn't work. Okay, that's why the ID maybe is a better way of doing it. But either way, going back to the button, you can now see that on click, so once we click on the button, it will execute the button controller on button click method that we defined ourselves, right? So let's actually lose the game real quick and see how we can reset the game. So we lost. Let's click replay. You see, we have basically rebuilt the game. And replay. And you see the name. Is it always going to be the same? No, it isn't. Okay, so now it's RR. I'm not sure what that name that was. Boris, I believe. And now it's Matt, I believe. So let me add Matt. You see, we won. Let's replay. And this was Mary Jane, something like this. Okay, so we win using Mary Jane. All right, and that is how we can reset our game very quickly using the scene manager. And yeah, just make sure that you save your scene in the state that it is, and then it will reload the scene with what it is at this point. All right, and that is basically it. That's how you can reset the scene, and that is our game. So you can now export the game and make it playable for everyone who wants to play it. And that's what we're going to look at in the next video. So see you there. Congratulations on building your first real game, because the other games, they were very limited, but I believe this one was already quite a good start. And you have used a lot more programming techniques. You have seen how to use the update method, what delta time is. You have seen how to use methods a lot more, and how to use arrays and so forth. So now you are ready to build your own games, even though they might be quite simple and you will have to look up a lot of things when coding, but that is not uncommon. So whenever you come across a new feature that you want to implement, what you would do is you would research how to do that. And usually you would find a lot on the Unity website. There also in the forums, people are very helpful and help out, or on Stack Overflow. That's really something that most developers do a lot. We research and we try the code that we find. We then modify the code so that it works with our project, our game in this case. And well, sometimes it works, sometimes it doesn't. If it doesn't, then we search for the next one and we try it. And that is something that is not a very uncommon. So you could, of course, go ahead and try to do that, but I would recommend to just build the next game with me, and then you will feel even more comfortable, and then maybe you can start building your first games. Even though there is no rush, you can, of course, also just try to only implement certain parts of the games where you feel like they're a repetitive kind of concept, something that you have learned earlier. Okay, and that will happen the more you go through the course, more and more often. So you will see more and more features that are pretty much the same. In this case, you saw that the graphical user interface was something that we have used before. So you could have done that all by yourself, or at least parts of it by yourself, and that will become more and more easy in the future. All right, so see you in the next chapter, where we're going to build our first real 3D game, a 3D platformer. So see you there. Thanks a lot for watching this video. I hope you enjoyed it, and now you have a certain understanding of how C# programming works. You have built 2 games while doing so. I hope you also coded along, otherwise it wasn't as efficient, I assume. So now you can get started building your own games. And there will be another video that comes just after this one, which will teach you how to build another game, where we're going to combine Unity stuff, so the Unity physics, features, and all of the good components with C# code. So we're going to build an even cooler game, a platform game in this case. So definitely check it out. And also, if you want to get the full course, which doesn't only include these 3 videos, but includes all of the other games, like the first person shooter, like the Fruit Ninja clone, as well as a Hausmeister Tycoon game, then definitely check out the link in the description. The course will make you a real game developer with Unity. So see you in the next video, and hopefully also in the course.